Good morning. Welcome to our 554th dive. We are back down 2,514 meters below the surface of the ocean at East Pacific Rise. We have returned to the sites for experiments 2 and 3. For today's dive, we're looking to recover experiment number 2. So if you tuned in for the recovery of experiment number 1, that was quite the exciting dive. We're looking for another recovery today of an experiment. So again, this is live footage. This is the remotely operated vehicle Sebastian's 554th dive, looking to recover experiment number 2 on our Underworld of hydrothermal vents expedition. Right now we're looking at experiment number 3. You can see that bacterial growth that we've been seeing on these boxes, and not just on the outside. When we lifted experiment number 1, it was filled with bacteria. So experiment number 3 certainly looks to promise another bounty of bacteria, but that's not what we're here for today. We are here for experiment number 2, which we're panning to right now. After collection of the box itself, right? We first have to puncture through the mesh. That's the first thing. We're going to draw out some water from inside the box. Then we'll be lifting the box. We'll be suctioning out bacteria, and then we'll be looking to sample the rock. And last time we did that, it sampled quite the chunk of rock up out of the seabed. It's very exciting. But after the collection of experiment number 2, we will also be supplementing that with further samples, time allowing. See folks starting to trickle in, so welcome, good morning. I see we have some folks for whom it's a very early morning. But also good afternoon or good evening, depending on where you might be joining us from. Through the dive, you'll be hearing the voices of the folks in mission control. So right now we've got Sabine over on the camera and Science seat, and currently we have Chris and Russ in as pilots. I'm sitting in as the multimedia technician, but we also have Tomer right now back as our MT and data logger. Oh, but we might also be having a pilot handover right now, so.
Just keep an eye on that bag at the back. I don't think it'll push it, but you've seen it in this camera, so just push it out.
Yeah, it might be an issue.
So one of the things that will differentiate the collection of experiments 2 and 3 from that of experiment 1 was that for experiment 1 we cleared away much of the growth that was already present at the site we were deploying the experiment, but for 2 and 3 we actually left some larger tube worms intact in there. So be interested to see. course, like we said, that whole box might be filled with bacteria now anyway, so. All right, we do indeed have a pilot handover happening, so it looks like we're having Alex jump in as pilot, and Chill's going to be on co-pilot. And then another Alex, myself, over here as the multimedia technician.
Could you make the image in the shop?
Again, we are at the site for experiments 2, right there, mostly center cam, and 3 over on the left side. And we're hoping to recover experiment number 2 today, having recovered experiment number 1 2 days ago now. We're looking for a bottom time of roughly 8 hours again today, but that can be modified based on our objectives. So, internet's looking pretty good today. I know yesterday we had some interference from weather a little later in the dive, and then unfortunately our efforts to bring you the ascent just did not come to pass. We did have a little weather earlier this morning,
Okay. So
but
we can go to the other side.
right now it's still
And then we
looking
can
a
start
bit
the
overcast out
mechanical
there.
process.
We do have some stormy looking weather, so we'll be keeping an eye on that and working to bring our internet through it if we can. For the collection itself, for some parts of it, the pilots will be quite focused on that, as will the scientists. We'll try to keep narration low, but this first portion, puncturing through the top of the mesh, we will have to sit here for a while and suck the water out from inside the mesh box here. So, a slow start and then all at once is kind of what the last recovery looked like of an experiment. So down in the lower left, you can see some data from ROV Sebastian there. Our depth currently 2,514 meters. It'll stick around that for the dive. You can see also the temperature that ROV Sebastian is currently in is about 1.9, 1.8, 7, somewhere around there degrees Celsius. But we do see that kind of come up past the 2-degree mark every once in a while for the ambient temperature as we pass through some hydrothermal flow. And then we've been probing some areas of flow as well. yesterday we found some quite hot over by Chimneys, but even just in this area it can get up to about 20 degrees Celsius or so.
There's a loch.
Yeah, but I think that it's covered on top. It's coming from, I think. You have to see.
Sabine and Monica are giving a close look over the experiment before we recover it. Just noting where there might be some flow under the seal there.
Allerdings uns aussuchen kann er nichts.
Any, yeah. Darum meine wir haben da. We put here, we had put glue. So I think it's like pushing through because the tubum is here.
Looks to be a crab emerging here.
That's not good.
Die
It is,
make a picture.
Yeah.
So,
oh, shit. Oh.
Is this the one that had a crab in it?
Is this the? I feel like 3 had a
No,
crab
that
in
was
it as
number
well.
3.
Yeah.
this is free now.
No, this is 2.
Oh, this is the one we want to.
That's not a pink crab.
Okay.
This is the hoe?
Yeah. So this is
Yeah.
one of the
Yeah.
crab that we've seen
Yeah,
around.
this is a hole.
And so there is a hole in this seal on this side of the box.
Outwards, not inwards, but because you could see the white stuff getting out. Which you could see it in the video, but
You might have heard Monica there mention that at least with this hole, there is a flow coming out. So preventing ingress of smaller particulate
Yeah,
or
because it's
planktonic
like
fauna.
where the bacterial growth is, because we put here a lot of the glue also.
was this glue you glued? Can you see
Here,
it?
no, but it's here, this
Yeah.
blob.
This.
Like you cannot see it
No,
now,
you
but
cannot see
we have to look afterwards.
Okay, the video of the crab is pretty. There must be a hole because
Yeah.
not because also the crab, but because we saw the fluff, white fluff
yeah.
coming out.
Yeah, I think is it destroying it? This could be.
Yeah, they could be. Maybe we just trapped this thing, and so now I think they can go in and out. But maybe I don't think it was trapped. Sure, comfortable cave. So here, but on the other hand, it's really clear that the flow goes out.
Yeah, sure.
But it is better than nothing. Yeah.
Can you make a note on it? Just observation.
White, right? White. You met exit from that box. Just like a flow, so.
I wonder if it can really go in or not, because it should be blocked. If it's just, like
Digging it now, but the fluff comes from the inside.
inside, yeah.
So whether it is super small or big, I don't know,
Yeah.
but it's for sure.
That's for sure coming.
The flow comes from the in and out, and the crab. Da schau dir an.
Working through the silicone. Oh,
Das kommt jetzt. Juppie, wie weg eigentlich.
Suspicious.
So again, if you're just joining us, we have returned to the sites of experiment 2 and 3, looking to recover number 2 today, and we're currently watching a crab emerge from a hole in the silicon seal.
chisel poking it out.
Again, these experiments are looking, as the name of the cruise indicates, right, the underworld of hydrothermal vents. These experiments are looking into questions about what is actually under these vents and whether or not the organisms that are found at these vents might make it into that underspace, that underworld, and survive there. And there was certainly evidence with the collection of experiment number 1 of organisms living down there. So again, the idea here is that you do have these organisms, such as the large Riftia tube worms there, that you can see those bright red and white lipstick tube worms. You have them at these venting areas. So this is diffuse vent right here, compared to, say, like the black smoker chimneys, which are very, very hot water. And this water comes up from below the ground. It originally enters the ground in an area known as recharge, and that can be quite far away. And the water enters quite cold, right? It is deep ocean water, and it makes its way down before it is geothermically heated and very hot, to the point where that should really just sterilize anything. It has no oxygen at that point. It's completely inhospitable for something like a tube worm. But at these diffuse sites where the water makes its way over to and it starts to come out, there's still some exchange there, very likely. And these diffuse sites are much lower in temperature. And so if there's a little bit of exchange, a little bit of entry of water from above the ground to below the water at these sites, it's possible that something like the fertilized zygotes of the tube worms could make their way into the underworld, right, into the water below the ground, and then via that water could potentially travel to other diffuse venting sites. And so that is what is being tested here, or what's being looked for with these experiments. By placing these boxes over top and attempting to seal them to the seabed, the scientists, in essence, have extended that underworld up. Right? They have extended the ground upwards into this box. And so when the box was placed, they stained with a dye everything that was under the box, so it all should have color to it. And anything that arrived afterwards, assumedly through the venting flow itself, would not be stained. So when we lift this box, we're going to look for evidence of things underneath there that do not have that stain.
I don't think he can go in. Yeah, he's like below.
He's like below, I think he's in the silicone. Now we see where the
Yeah.
So right now they're just testing. They're curious how far this crab has actually gotten into the silicone. And it seems like it may not be able to get all the way in there. We have seen some bacteria coming out. You can see some bacteria coming out through this flow, but they're not sure just what the whole situation is as far as what hole was punched through that silicone. So
I see his body when we're almost like.
yeah, we've got new folks in the chat, so welcome. Yeah, if this is your first dive, this is kind of an interesting one, or if this is your first expedition, right? But we have expeditions planned for the rest of the year and on. You can actually find out more about this expedition and the others planned for 2023 at our website, schmidtocean.org. I'll post up a link to the current cruise, its page over there, where you can learn background about this expedition, the ideas behind it, as well as some blog posts written by the scientists themselves. But again, from the cruises page there, you can actually look at the other cruises that we've already done and the other cruises we have planned for the rest of the year. So give me a moment, I'll post that link up. And if you're joining us on YouTube or Facebook and you're watching live, you can type any questions you might have in that chat there, and we will try to answer those as we can. Again, we might be getting quite focused in a little bit, and so might get a bit quiet here, but we'll try to answer those questions as we can.
More of a live side in there.
I think we know enough.
And I think when you remove, you have this mat on the floor.
Yes, and then you
And then
also
you can also see if it's beyond the frame.
Yeah.
I don't know.
I think another, like more like from this side, I think it would really help us. Monica, do you want to look more from this side? Monica? Should we try to look more from this side then? Or are we good?
Yeah, I mean, it's difficult to say whether also there's for sure flow coming out because we saw this fluff coming out. That's clear to me. Whether the hole is big or not, we will see, I guess, when we take it off.
Yeah, but I know that right here under we have this
Yeah, if you're joining us just now, you may have seen us recently in some news coverage about our last expedition, the Octopus Odyssey, which was quite successful in its objective of looking for more octopus nursery sites at venting areas. They did find the third known octopus nursery at a venting site, which was very exciting. And now we are on this expedition, the Underworld of Hydrothermal Vents, which again has so far been quite successful in that we have pretty solid evidence that organisms can make their way into that underworld. But we still have two more experiment boxes, two more of these mesh boxes to lift up and check out. But with the recovery of experiment number 1, we were actually able to pry up a section of the seafloor and view down into that underworld. And see that, yes, indeed, there were worms that had made their way down there, as well as bacteria that is growing down there below these diffuse venting sites. But yeah, the octopus nursery coverage recently probably had some little octopus babies in the footage. We did see several of those hatching while we were on that cruise. And I have posted a link to the cruise page for this ongoing expedition right now, and I've pinned that in both YouTube and Facebook. So if you're interested in learning some more about this expedition, go ahead and click that link, and while you're there, if you just visit the general cruises page at schmidtocean.org, you'll be able to see both our past cruises as well as our next few upcoming cruises for the rest of the year. And if you have to leave at some point, you can't follow the live dive the whole way through, of course the recordings of these dives remain up on our YouTube channel. And you can also follow along using the hashtag #VentUnderworld. VentUnderworld over at Twitter. And there's been posts there from scientists on board, as well as images and screen captures from the dives themselves. Alright, so this is the probe by which Sebastian almost becomes a mechanical mosquito for this portion of the recovery. We're going to puncture through the mesh of this experimental box and begin sampling the fluid inside the box.
This is what it is.
Still have to reposition. So you can still relax the heat.
No.
After the box, immediately after the box is taken off.
After the box is sent, it was only taken.
Yeah, taking off is slow, right? Yeah.
I see that feels like On the left side there, you can see the metal frame that was used for planning out the deployment sites of these boxes, being roughly the footprint of the box. We were able to use that frame to find nice, flat, level areas and determine sort of how much work it was going to take to seal those areas up and how the box would fit in them. We are going to be taking some geological samples here, but whether or not those geological samples are quite as much of a plug, a door to the underworld, yet to be seen. At the very least, we want to get some of the geology underneath this box.
Last one, we didn't do the big hole in the center. Was there a reason for that?
Yes, because I'm afraid if it's kind of, if you stick in and then it's moving, you make the hole actually bigger. So kind of, if you're in a small hole, you protect that it's like, that the mesh is like,
Sure.
gets larger.
I think I don't know that would stop. If that arm moves, I think it just move the box. I see your point. The gelatin should have one thing in it. Right? It worked last time.
Yeah.
We'll see what it
And it doesn't matter, which of these holes you pick. This doesn't matter, like either like this or these here, and then from the inner. Yeah.
First move. Not pulling tight. Ish too.
I think probably it looks like it's not hearing, but I can
Let's work it out.
looks good so far.
And do me a favor, zoom out. Let me just check the angles. Boxes. A little bit of angle.
Good.
Yeah. Can't remove it.
Think about that, so.
Nice and smooth.
I need to reindex, go for freeze. So awesome. Just move on. All right, frozen.
Well done, Joe.
So first need to come out for 2 minutes.
1
1 minute.
So as you saw there, we pierced through the mesh of the box. And this is going to collect water into the bag on the back of the box.
First direct out touch of water.
Good or what?
More blocks, you see that in the back.
Good.
Stay 1 minute and then just go back. Leave more.
Yeah, yeah.
Yes, that's what.
So right now we're expelling a bit of water from the system.
Okay, you can do.
And the system should now be pumping water into the bag. So again, that bag is this one on the rear of the submersible. And now it'll take usually about 35 minutes, I want to say. Ultimately, we're collecting something close to 55 liters of fluid from inside the box here. See some folks talking about the mobula array that we saw the other day. It was still around the ship yesterday, but it did not come and say hey to us as we were recovering.
Think of 11, right? So tiny degree change. It's like inches over here. It's like,
Did we sharpen up that needle?
did we have to sharpen the needle or it was still good?
I sure.
Oh yeah, it seemed sharper. Yeah. Yeah, no, Chill did a real smooth job getting the probe inserted into the mesh box there.
Yeah, well, you left this already, no?
Yeah.
Okay, then.
That's all number 100 and changes.
Oh yeah, it's changed. Yeah, it's feeding. All good. Yeah. Very good. Oh, so, this was in the beginning. So,
So what is your sample number?
110.
Yeah. All right.
ROV bridge.
Go ahead, Rich.
Hey, I'm just going to come another 10 degrees to port.
Okay, we'll put a movement for you.
Cheers.
So we kind of want to put a ways behind us to the west. Just under 10 port. Oh, I realize you had it. Sorry. Go ahead. Rich.
All right, so the bag does appear to be inflating, which is great. So now we'll sit here and collect our water sample. After that, we'll move
We're
on
on
to
that waypoint now.
actually lifting the experimental box itself, which, if it's anything like experimental box 1, it is filled with bacteria right now. So we'll then work on collecting the bacteria, and then there's some more sampling after that. Been streaming for a while, and folks have been trickling in, so if you're just joining us, we are currently sampling the water from inside this mesh box. We're back down on the East Pacific Rise at experimental sites 2 and 3, right now at 2, although we did look at 3 earlier. About 2.5 kilometers down. As you can see, as I mentioned a little earlier, the ambient temperature has bumped up a bit around us. It was about 1.8 when we were settled down in another place, and now we must be settled down slightly in some diffuse flow because it's bumped up over 2 degrees C now. Still chillier than you would want your bath water, but evidence of some warmer water coming up. There are some organisms you can see in this area here. Of course, we have the large Riftia tube worms, which are kind of those red and white looking lipstick worms. There are some crustaceans as well. We have little swarms of amphipods in the water column, and then on the camera right there you can see one of the types of crab that we have, or one of the types of crustacean we have. We have these, and then we have squat lobsters, which are more related to, say, hermit crab. So lots of worms. We have those tube worms, the Riftia with the red gills, but we also have some little tube worms that have white feeding apparatus out. So this crab looks like it's been in a scrap, lost one of its claws. They can, of course, regenerate limbs. It'll happen as part of the molting process, though. So a younger crab molts much more frequently than an older crab, because molting is also how these animals grow. So depending on the age of the crab, it might be a while before it molts. But you can see another organism here, as mentioned in the chat just now. A lot of bacteria growing here, all that white. People keep saying it looks kind of like yogurt, or I heard cheesecake. But yeah, that's all bacteria that has grown and is kind of growing up from the mesh through the holes in the outer box. And we have witnessed the crustaceans kind of cruising around and feeding on the bacteria.
So these are the primary producers down there. So basically, on land, you have the bases are the plants that produce the biomass.
You can hear
the bases are the bacteria, all this.
Sabine and the pilot speaking over on the other side of mission control right now.
That's the reason why they're going there, because there's food.
Look at the amount of larger biomass and realize how much bacteria has.
Yeah, it has to be there. Yeah, it's amazing. It's insane. Yeah.
But currently, because we're sampling that water, we do need to stay still while we do that. So this is always an opportunity for us to kind of just stay in one spot and zoom in real close and get more of a look into the lives of these animals.
Yes, yeah. Lekker verlimpet.
Yeah, Alex and Sabine over there just noticed this little scale worm, this little red scale worm at the top of the box. Well, below the top of the box.
Also like limpets on the crab.
The crab, the limpets are just eating the bacteria off of the crab.
Limpets, they're grazers, so they're just like, yeah.
And then another organism here, seeing are these mussels. Do you see quite a few of them around? It was discussed that these are kind of one of the later animals to show up at a lot of these venting sites. The bacteria show up, of course, the worms show up and grow, but then the mussels can come in and actually sort of choke the worms off from access to the venting water in some cases. So.
And Mike, oh, sorry.
A nice close-up at those Riftia tube worms. You can see the red gill structure up top, and then of course we have the white tubes themselves. Got a tiny little crab at the base of this tube worm. Off on the right side there, right bottom corner. Teeny tiny little crab.
Where's it cut off?
Right at the base of that tube worm. Kind of comes in.
Run.
Yeah,
And down, you touch.
there he is.
Oh, no.
Looks like this one's been hanging out by some bacteria. A bit fuzzy. The bag, let me put up the bag. There we go. Bag is continuing to fill back there. You can see it's making some progress. So just collecting our water sample before we move on to the recovery for the box itself. See these little limpets around, fastened down to the rock, but there's also some on the tube worms and mussels there, as well as these little anemones right in front of us. Got some real nice shots there of sort of the texture of that tube structure. As well as the gills. Just real nice contrast there between the red gills and the white tube.
Amazing.
The geology that these are
without a cone.
It's not a texture I expected for them, honestly, having ever seen just pictures of them. Yeah.
Ja.
En nog wie heeft de neem te liefde?
The worm comb.
The lifter name, I don't know. It was also, it was here.
Yeah, but like why? What's the, is the meaning for the name?
The meaning, I don't know.
Makes me a little jealous.
I can look it up. See, I look it up, I know, I have the species description here.
And again, these worms can draw down into their tubes, sort of protect themselves, defend against predation. But when they're feeling safe, they're pretty well extended out here.
Yeah, so it comes with association with the rift songs.
Yeah.
Also because of the rift.
Galapagos
Yeah,
rift.
yeah.
Yeah, this is true. It was your discovered the
Galapagos.
rift.
What's the meaning of Hydrothermal? Hydrothermal? What's this?
Grab my back there.
It's hidden. You can't see it there.
See?
What is that?
A small crab, like a megalope,
And it's hanging on.
hanging on the.
Yeah, I was curious if that was a molt from a small one or what.
Yeah, this is like a
Yeah, some molted.
So, Hydrothermal comes from the ancient Greek parcus, meaning dense or thick,
Okay,
with plyton, meaning feather or plumage.
okay. So thick feather from the rifts.
Yeah.
That's what it means.
They're discussing the species name of these riftia worms. Oh, we have an interesting, like isopod or something to the left. Little amphipod tucked in there. Oh, yeah, little. Oh no. What do we got? Yeah, the shrimp.
Shrimp.
Yeah, yeah. Nice.
That's just eating the bacteria off
Yeah.
the intestines.
Just picking away. As we mentioned earlier in the expedition, I think we were discussing the concepts of tube dander, as these tubes are quite flaky, but as well the bacteria that kind of grows on everything around here would be a good food for that shrimp as well.
Those eyes are pretty fun. So, so the deep sea organisms that have what look like eyes, but don't, I'd imagine don't use them.
Yeah, it's so many of them have reduced eyes, so don't have eyes anymore. And for example, like I don't know from this species, but there's like a relative of it, Rimicaris, which is living in the Atlantic Ridge, and they actually have developed like a new sort of eye. It's kind of a photoreceptor on the back, which kind of can detect the illumination of the low frequency light, actually of the black smoke that's coming out. So it's a novel eye in this eyeless shrimp, like on the Mid-Atlantic Ridge, a relative of this one.
Yeah, we were talking about this the other day. The concepts of like the infrared light that's technically emitted,
Yep.
and looking at green sulfur bacteria that it's doing the process of photosynthesis, but it can only do it within about 3 centimeters of the vent because the energy from the infrared light. The infrared glow is actually enough to carry out its photosynthesis.
Yeah,
So
yeah,
it's just
yeah.
fascinating. Yeah. Here in an area with no light, no sunlight, there is still light, right? No sunlight, but there's enough glow coming off of these hot vents that this bacteria can actually photosynthesize still. But of course, much of the food network here, the food chain, trophic network, is based in chemosynthesis.
Almost there, 7 minutes.
Freshly baked bread. It's so good.
Start the others.
That way, but,
Oh, exciting.
Reach the
Energy is so.
yeah, at the growth first.
I detected your vote. it all go like zip tie to a break. It's just like that. Well, I just
Yeah, I was just looking for that study. So it was the green sulfur bacteria, part of a 2005 paper. And it looks like it was from East Pacific Rise, where they found these green sulfur bacteria that are potentially using the dim glow of the venting to drive their photosynthesis.
40 seconds.
But if anyone's wanting to check that paper out, it's an obligately photosynthetic bacterial anaerobe from deep sea hydrothermal vent from 2005. So that's a cool paper to check out. A lot to learn about these vents still. So we're still... There we are. You might have just heard that timer. I was going to say we're still waiting on the timer, but there it was. So, with that timer, that's the end of our collection of water here, and we're going to bring that to an end and move on to the collection of the mesh box itself.
It's all messed up.
So we've had an issue with perhaps the vibrations of the ROV itself, turning this pump back on a little bit. So we're just going to try and secure it there.
Good, very good.
We're going
So we'll see if we get a little plume of bacteria coming up from this puncture site. Not too bad, but a very smooth removal there, honestly. So it's possible that that bacteria is not too disrupted inside the box.
Will the arm move this thing here?
It's all the way down. Can't reach it.
Okay.
Take a look to the left here. Plus we have a bungee holding it down.
That's
Yeah.
what she's talking about.
Just like that the arm probably push the, you know,
That's pretty
it's starting to move basically the pump when your arm is moving in this direction.
I mean, this part is flexible, but the
Yeah.
bungee's still pulling that way.
Okay.
I think all I can do is just kind of move
Yeah.
it down.
Okay.
Alright, as they're stowing away the probe there, you can see that the bag itself is now quite full.
Okay. So the next step is to lift up the mesh box and suction the fluffy stuff out of the mesh box. And the last time we moved it a little bit in this angle so that not all the stuff can escape. So of course first there will stuff escaping. Then you keep the box basically straight. And when you start suctioning, you move the box a little bit in this angle that you can see what you're doing. So basically you want to catch the bacteria that are trapped in the box. And we use...
You might be able to get up with the strapper arm,
And
and then come this way with the forearm, and grab it and make her do it. Yeah, I agree with you. We can get up and get on that other side. I think that's better. Yeah.
it will be the suction jar number 4. So war das die Bag heute?
Ja, also das erste Mal.
Alright, so the pilots are conferring how best to approach this, but basically we're going to want to lift the box up, but also suction the bacteria. Last time we lifted the box up and a lot of bacteria came out, but there was still enough up inside the box to vacuum. This time it sounds like we might try to hit hit it at the same time as we're lifting it, but we'll see what the pilots settle on.
What do you think birthdays will look like? In the box.
Yeah.
Are they gonna be active?
I don't know. I have no idea. Probably not.
Did you see the, unfortunately, the temperature of the 2 or 3 days?
Sucks.
Not sure why. Yeah.
For 10 days. actually.
Yeah. It's almost like the temperature was, you know,
Yeah, it's fluctuating.
wasn't pretty stable.
This way to get you closer.
Maybe just, you know, we're going forward.
So you can see the suction sampler being held in the manipulator there on screen. For folks who might not be familiar with it, the suction sampler, kind of like a big vacuum cleaner. It's actually got a hose that will, it'll suck up debris, or in this case some bacteria, and that hose will deliver it back to the cylinders on the aft, or excuse me, on the starboard side, not on the aft, but there they are, getting the correct cylinder. So we're going to be collecting into cylinder number 4 for this one. And you can actually see kind of where that is here. So you can see our main science camera where you view most things. You can see the suction sampler there. A little bit of a hose goes up off screen. Actually, I can show you a slightly different angle here. So you can see the hose off to the right there. That goes up. And then it comes back down. You can see over by the light where it comes down and goes around, and then back to this view. You can see the cylinders back behind the camera there.
Yogurt.
And you can, I think, lift it up a little bit more.
Go higher.
Yeah. And you can go more in with the suction. So. Yeah, I think Alex, I think if you can flip it a bit, and then Carl, you can go inside. Dat is een workshopstuk.
Get this under in case it slips out.
Yeah.
Gets
Yeah.
picked up.
So much stuff, huh?
I think our jars clogged anyways. We're not doing anything at all.
Okay. That's okay. It's outside.
It's outside. Yeah. Just wait a bit.
Figure out our jar.
Do you want to switch jars or hydrological jars as well?
Yeah, it's not. So it's
Put it slowly.
yeah, it's not really set up getting organized. Which one was this? This was for.
That was fine mesh.
Let's see if there's still anything left with also as well.
This is on 112. This is rolling with 5 to 5. And it's going to.
Good.
Yeah.
Just a heads up for folks. The weather's been looking okay this morning, but we do have some dark clouds out there. So if those happen to get to us, our internet could get a little spotty. So I'll be keeping an eye on that, and hopefully if it happens, it'll pass quickly, and we'll be working to get the connection nice and stable for y'all if it happens to get flaky.
So it's important that the sponge is moved as little as possible. Basically ends up. And the last time they picked it just below the first sponge on the iron chain, because otherwise it was a bit too high to get it easily in.
So the little white doodles on the seabed are little tube worms, but all that white, flaky,
Just one
blobby
moment,
stuff
sorry.
that came
We
out
want to
from under
make
the
a
box
frame
is
grab
all
for
bacteria.
a
Yeah.
highlight frame grab. So if we can, if we can go back. The two worms are dead.
So I think the first thing we want to do with that is
Cut the. Yeah. Have a highlight frame grab? Yeah. Very good.
We have to grab it another with it. We're going to open another jar.
Oh.
We're probably not going to know, because I can't see that way unless so if I have to just look away.
Even if
I don't see it. Broke. Okay, let's put it in
well, it's still,
three.
still a list of 3 to 1.
Yeah. Okay. So for
You want to grab it and look at it, or just using kind of like a coral cutter.
I don't understand the logic of using that on the field over there. That's me.
Yeah, I'd say you just cut it like a squirrel, grab on it. Where the zip tie is, so you the whole of the zip tie, so you just get the loop on it. So you can.
Also, I think it's also okay to like break the zip tie once the sponge is in the quiver, because then all the stuff that would fall off would stay in the quiver. So depending on how much movement this causes, probably can still do it, when the sponge is inside already.
So this thing is coiled, you want me to grab below the first sponge, right? You know where
That's
that
not
is.
possible, yeah. So probably, if it's well, we can grab it here just above it. Then it should still work, because the last time we had to use like one quiver further back, and then it was a bit too high to get it in. But now we're like a bit further, like in front, so it could work out.
This is amazing. I can't believe it.
It looks like only the zip test can have it, right?
No, there's that little bump right in the base of the
All right, so finishing up the collection of the sponges here, and those sponges are a little substrate that was put here for the bacteria to kind of grow on. Bacteria and anything else that wanted to settle out from the water. There was also a temperature logger in there that would record the temperature fluctuations throughout the deployment of the experiment, and an acrylic settlement device that's been successfully used to get tube worms before. So when these sorts of things are deployed, oftentimes they'll use a little knot of buoyant rope so that the ROV has something to grip onto, but then obviously now we have to work with something that floats. So pilots are just working to get that down in the container.
So,
Grab on stuff.
awesome.
Can you break the zip tie with the other arm without the rubber on?
Won't fit. Worse.
Mm.
Doesn't reach that far.
Okay.
Or if you twist it as you're shipping it down, it would stay. You know. So that's pretty good. Keep it on. Yeah, you got it from here. And you put the two.
That's why Zach wanted us to break the zip tie before we got over here.
Yeah. But I'm still happy that the sponges are in, so that's good. Is it also an option to, Monica, can you also listen? To just close it and like, so that the red rope is still out, and the only thing that's in between is the zip tie?
Just press
Yeah.
it down.
Yeah.
No, it is true. There was some so it's
Oh, what?
Very good.
So we just decided it's fine if the rope is out. We'll just close it on the zip tie.
So there's no option or anything? No, okay. No. And was lost. Yeah, okay. Very good, thanks a lot. Okay, so this was sample number 113. Sponge and trap in quiver 1. Okay. Inhale, exhale. So the next thing is that we remove the mesh box just to get a good, view on the area, because now like one corner is a bit in there. And then today we want to use the suction sample first to go over this surface area here. And we do this with the very fine mesh in suction jar number 5.
We've used 1 and 4.
Yes.
And that's over just in case for something else. So you don't understand that.
Use the fine. We want to use the number 5, the very fine 5, what we already have. Good. And before we do the suction sample, we want to get a good frame grab.
Yeah.
So we're coming up on 2 hours. Means we're hoping to have about 6 more hours on bottom time here. For anyone maybe just joining us now, you are watching live footage from the remotely operated vehicle Sebastian being controlled by the research vessel Falcor 2. Sebastian is currently 2.5 kilometers below the surface of the Pacific Ocean at part of the East Pacific Rise, about 2,000 kilometers to the west of Costa Rica and 1,000 kilometers south of the Mexican coast. We are collecting back up one of 3 experiments today. We collected experiment number 1 2 days ago. Today we're collecting experiment number 2. So first we punctured through the side of this mesh box that you might see lying on its side there, and we sampled some of the fluid from inside. Then we lifted the box, which was again full of bacteria that had grown just over the time that it's been deployed here.
That's what I'm asking. Does anybody know if that's what, is the bag fuller, or is that how it's been?
It's how it's been actually.
And now we're going to be collecting some samples from the area itself, underneath the box. So I have to hop out for a little while. I'm going to hand it on over to Tyler. So you'll be hearing his narration on and off, as well as the scientists and the pilots.
Thank you. Oh, it's 2. Ah, no, the other together. Do you know, this is like, it's colored. That's nice.
That chromosome.
Now here, there's a little crab.
Do you think this is
No.
where you die?
Here,
Ah,
a crab.
is that?
Ah, cheers.
This is there. If you totally zoom in, this is a mega local of the other one.
Yeah.
Ah,
But the 2 months of it.
Mhm.
Well,
Okay, so we now want to clean the area with using the suction sampler. And we take the jar number 5.
Number 5?
is this a little bit dye? Is this pink because of the dye?
no.
Yeah.
Or it's definitely been used. It's pretty crazy.
Okay.
And now we clean with the suction sampler. Go over this area here. We clean it.
It's dye, no?
The crab has a color. This is not the natural color.
No. It's stained.
It's stained.
Yeah.
So it survived this whole day.
You see that the muscle is stuck in the, in the chair.
Okay, so this is actually 100.
And it's important to stay inside the area. So here and yes. Mm-hmm.
You have the 5.
Mm-hmm.
Is there any type of mesh that you have?
Ultra fine.
Ultra fine.
What's that? Ready?
We try to go inside here, but
Then we can make two worms to the
that's also good. Yeah.
No.
Breathed in by inside. Huh? Yeah, I breathed down inside. Well, it's just-
Okay. Yeah, then the back it's not a lot of box left, so not so like probably here. Okay, so, yes.
What about the muscles? Are they? It seems the muscles are shut right.
Looks like they're alive. Well, normally when they're that way, yeah, but
Who's that?
I think we're, Monica, I think we're good, huh?
Huh?
More suction sampling. Probably once more over the area here.
This thing is in the way.
Yeah,
We drop here.
yeah, here and then. No, more inside, more inside.
Yeah.
No, I mean if you cook muscles, the one that stay closed actually that you shouldn't eat.
Probably here once more, and I think then we are good.
The muscles are alive, the two ones, the large ones are
Yeah.
dead.
You shouldn't eat them.
the muscles are alive because they closed now. They're alive? They're closed now. That's crazy. Huh.
Perhaps we'll soon come into our rift here.
Yeah, they're just waiting.
Yeah.
Okay, I think that's good.
I'm already there.
Yeah.
So we can put the suction sampler back. And this is sample 114.
Yep.
Suction jar number 5 on the south inside the box.
Can you zoom in the place where it was?
Sorry?
Could you zoom in the place where the frame was? So is this the part in which it has the opening?
No, this
No?
is no.
Okay.
But you got the limbits, no?
Hmm?
The limbits?
Yeah, I think limpets and we should then also see if that's
It's a shrinked troposphere.
Can I get it a bit in focus? Thank you.
See it like that.
best when we have taken out the larger inlets. And then we can go with a coarse red, for example.
As well here.
You know.
Is this dyed? No, this is like reddish. Looks like an haze.
I don't know.
That one's sick.
Yeah. It's called. The small crab. Actually, we have like a. No, that's limpet. That's the crab.
It's all crab, no?
No, that's another one.
No?
This is the one that's just coming in. The other one was like really red.
No, not the red one, but because it's maybe the one that was sitting
Ah.
there, they filmed first.
Ah, yes, yeah.
This is the one.
Yeah.
That's what
Yeah.
the guy we knew already, because back in his home.
Yeah.
This is like his place
Yeah.
now. This one. I'm gonna get this soon. This.
Yeah, cool. They are able to.
Let it get it.
Ja, passt schon.
They're much more.
Okay, take
Oh,
a
dog,
picture.
take a picture.
André,
André,
take a
highlight
picture.
frame grab.
Yes, yes.
Moving out. Come. Do you have?
Yes.
Okay, good.
This is like an eggs. What is this?
Yeah, a
I
red
know,
one.
We can
Yeah.
look at it, what it is. There are not many that are getting large also. Maybe it's not so.
It's Nereis.
Okay.
Okay, good.
Schau mal.
And then you also
Some-
see here
Yeah,
that's
I
colored.
just wanted to say this is
Yeah,
also the
it's
dye
also
thing
dye.
also.
So you can see the dye in the tentacles of the limpets. So before we make another highlight.
It's a little bit out of focus on it. Also, it's
Yeah,
not
it's because of the
focus here.
shimmer.
Yeah. Yeah, that's true. I think we can see. We can take pictures today also when we cover.
Hmm?
We can take pictures of the dye ones when we cover.
Ah, yeah. Yeah. Do we want to suck here? Oh, yeah. Wait. Okay.
The odd still here, but
Yeah, but that's like in the corner that I'm not, you know,
This here, yeah,
that's
okay,
in the
this one.
back. I would not,
Take in the middle.
yeah.
I think let's recover the animals.
The large ones get them in the roots, and then we do the.
Scrape over it again. No. No, this is not close, but first it was close. The second one also. Also so shimmering. Yes, get your
Okay.
Okay.
Should we move the large?
This is in the box for because I don't like this so much. We have two, no? The small one and the very cool one.
Mm-hmm.
I think.
And the rocks need for the cooler.
But then we cannot collect it also.
No.
Actually, we can put this in the cooler also.
Do we need those?
Yes.
Yes, because of the. Okay, then we have to put it in the cooler.
Yeah, let's put it in the cooler. It's not so. Let's put it in the cooler.
Mm.
If we do it now in the bulk box, we cannot get animals.
Mm. You know what I would do? I would only put probably the two mussel shells in.
you have to work on this, I think, because
Yeah.
then you have to bring all
And check for the.
I don't
Yeah.
know, this is not. I will put it in the
Okay,
cooler.
in the cooler because as only we cover the rock, you can still see like the apples. It does make a difference, no?
Yeah.
Okay.
Rock, and
Yeah.
we don't know what the rock is.
Yeah. Okay, so next we would like to remove the mussels and the tubes and put it into the cooler. The one from inside, so basically this one, that one, and these two guys.
Yeah, I might have to back up a little bit, watch out for the
Monika, hast du gesagt?
Yeah. Alright, I'm gonna watch out and see how much I have to do. Yeah, it's not, I don't want to go any further though. Let's back up now.
Yeah. Section sample 5. Yeah.
Just close up and click on resources or reserves.
Okay.
No. Yeah, not the point, then that's going to go way higher.
I shall set up on the board.
Yeah, yeah. Just set up Sarah, because I think it's the soft choice of the possible against the boot.
Right, so are we gonna have to have it
It would
open?
be nice to collect the muscles and see if
What's called open power?
to see if they're
How's that?
function of signals. They have been within the signal, so we will find that they're going to go.
Oh, we got plenty of space there. Actually, come up with
Yeah. Yeah.
Alright, pushing up. I'll get a bunch of.
How are you? Bring it a bit further.
Bring what?
Bring the box and the chairs covering. It's coming down.
Clear. Let's get this back.
What's that? I can fly us up a little bit now to we know where it to be. It might limit your ability to see science, but maybe get closer if you need to.
Maybe you can grab it on the tube below, like here. Yeah, yeah, right.
Oh man, that looks so bad. It's that better days.
Is this a new sample monitor?
Yeah,
150.
it's like animals from frame area.
Let's go into the cooler.
That goes in the cooler with the number
150.
115, yes.
Oops, sorry. Mm-hmm.
Yeah, no.
Just grab it.
Try to creep below. Also, yeah.
Maybe it scoots up a little bit. So it might affect your ability to see over the porch.
Das ist Warte, muss sein. Haben wir schon
So
die-
well, so.
Yeah, I don't know, the access, it's good.
Mal schauen.
If it's easier, you can also grab the mussels first and put them in.
We want to crush them, so I'll use the other arm for that.
Okay. Da ist auch alles in sehr schön.
Das ist gut. Das ist besser, das kannst du
Ja,
merken.
das ist gut.
Very good.
Das ist die erste, die ganz rauskommt, die anderen.
Da können wir noch einstecken.
Da kannst du eine stecken. Da haben wir 4 tot. 4 Tote. Und wie bei der, wie immer, die ist ganz relativ frisch geworden. Die schaut ziemlich gut aus, die anderen sind. Mal schauen.
Das heißt, du kannst ja noch Babys abhören.
Das ist die
Das-
Nummer 5, aber dann nehmen wir den immer mit. Ist wurscht. Das ist gut. Das wird gut.
To try to get like the whole tube in the hand.
A bit muscles there.
I don't know. You could hold it. Well, maybe. Forearm could getting around it. Notice it? You know what I mean?
Alright, let's skip that. So, these muscles there would be cool. Take the gill to do what next. It would be good to take the gill of the muscles to the mRNA sec to see what happened to the symbionts and also like microscopy. That's cool. Because they survived, no?
Mm-hmm.
If you want, got an idea. We hold it right there and we shut the blade, tap them into the thing. Right.
Well, I'll just need that scoop.
Okay. So you can push the scuba down a little bit more. So you go down a little bit more with that. That's what you do. Soft touch press.
Very good.
Would be nice. Check what happened with the gills of this. Okay. Jeez.
Well, it's good. Yeah.
Okay, very good. Okay.
Anything else you want to get out of there before we close it up?
First, I want to get a good overview of the area now, so a good picture.
So we can close it then, and else you want to take out of there before we do?
Yes, we can close it now. But like first have a look and then we'll see. But just need to watch out. This box is rather close. Okay. Okay. Can I? Yep. Okay.
So where's that chili food? It's like,
No, it's only at home. I got a few of them.
So we
oh, that's what
take
you
the
were
highlight
asking.
through.
No, I didn't do any. Sweets,
Okay. Monica. Question if we should take the suction sample to clean it a bit more, or to start now with the small bag, and I think we should start with the small bag.
Why? Coming out anyway.
Yeah.
I would suction sample over it now.
Over it now once again.
Yeah.
Then with
Take the coarse one
the
and
coarse
over,
one.
and then go and find the best holes.
Okay.
Yeah.
So we used 1 and 4. We could also use a fine one if you want. We could also use number 2.
You can use the fine one.
We
Ultra fine
use
we have now.
no. Ultra fine.
We have here.
Used the number 4, and the number 5 we already used.
5
yes.
is basically the, and now we go from 5 ultra fine to fine.
Yes. So now we take number 2.
2.
Mm-hmm.
Yeah, I would do this first because
Yeah.
my son is concrete and might have more.
Okay. So we take the suction jar number 2. And do basically the same what we've done before. Go once over this area here. So again, stay inside the box.
This one must have been inside because it is stained, I think.
Yeah.
So this one,
Mm-hmm.
just
Yeah.
notice
Mhm.
when it comes out, we will highlight.
Mm-hmm.
Yeah, you can.
Yeah, so number 2, you think?
Number 2.
What's inside? Yeah, coming on.
Huh?
So it survived.
Yeah. Number 2.
Could you hold it a bit more like this?
One problems with
Yeah, yeah.
Bungee's drill it.
Okay.
They're trying to press it this.
Be a little bit more. That's all we can do. We're going to be pushing back so that we have the good foot.
Till here. Yeah. And then go down a bit. So not over this area, but like here. Yeah. Whoops. Here we go. Very good.
This is with the fine mesh.
This is the fine mesh. It's chart number 2 with the fine mesh.
So this is 116.
Yes. We go a bit to the center. Up here.
Get rid of that or just keep it in the 2?
Okay, I think that's good.
The top one comes out again.
Mm-hmm.
We make a picture
Mhm.
because probably
This one? No, that one.
No. Where was it? I think it was this one. Sorry. I'm not sure, but it was in the for sure in the area.
Sorry?
No, just
No, no, it was sorry. That's down there.
under the which well,
Okay, good.
that was under the
Was that like the gap where we
no, there's a few way smaller this one.
Oh yeah.
Like this grab this
Yeah, what was this the place where we
Oh, the place, yeah, I don't know. I lost the flats. Could it be?
like a channel?
I think I would guess
Chisel.
you need to do
Test with the chisel how deep it goes in, and then we take from here the
right, and then we take the bridge
back.
or then we go
yeah.
in with the
It's the same thing. It's the same thing. The temperature and the silverback.
yeah, and then we go in with the chisel,
Mhm.
fine bag,
Mhm.
big bag, no?
Fine back. Like small bag.
Big one.
Yeah, the big one we already filled.
Oh yeah, we have it. That's why we have to go and make the fine print. Okay, good time. Got it. Okay. Yeah.
Okay, good. So the next thing what we want to do is to collect with the small bag that's attached to a temperature probe, like inside the subsurface, and to be sure that the hole is big enough and deep enough, we first take the chisel, not breaking the rock, but trying if it fits in here. Yeah? And then we use basically the same hole to put in the temperature probe where the bag is connected to.
Fortune out.
Again, a colored, correct? Mhm.
Yeah, it's not in the best places for you. Oh, I mean, when you first go down, it must be.
Just listen here.
Dump the scoop over there.
Then we dump it on the deck.
Okay.
Do you think we're going to do any more scooping around here?
No, no.
Good. All right, I'm going to start you.
Only, sorry. Probably we need it at the end when we do additional collections for tube worms and mussels. So we should reach it again.
Yeah, I'll put
Yeah.
it back in the basket.
Mhm, yeah,
That's
mhm.
all. Just, this is not really good.
Let's see if we can go anymore. Hold on. There you go. That's all we got.
Okay.
That close. A little slow. All we got.
Okay.
Do you want to get that first? Do you want to push it a little bit? Hold on.
See if I can reach it there. Okay.
Yeah,
It's nice pushing it almost straight as
I'm trying to figure out why it's laying like that. It's supposed to.
Hold on.
There, right there.
well, it's she's up and go down right there. That's it.
Open it up a little bit.
Okay. You try here. Can you try a bit more in this area? Try to chip off some, small pieces so we can get a hole that's large enough to take the water sample.
Well, try to be as pressed down as I can. Go for it now. Push it straight down. Let's do what it is.
No, but you see it's going inside. Probably.
One second. Okay, should be where the boxes to our left, the two of them. So, the two boxes to the left. That's fairly far away, but not really.
No, it's close.
Yeah, not this far away.
I think that this hole will be more promising.
It's not really getting deeper than that, it's just solid.
But the tube bomb is sticking in. So somewhere, of course, it's like I think smaller than the chisel. But the tube bomb that you pulled out,
We should reposition really. Because that experiment 3.
That was good.
Yeah.
Yeah, that was a good one.
Oh, what's going on? We got it jacked up by here. You can work from here.
Sure.
This thing shouldn't get too much squeezed.
Yeah, we'll need to pick that up.
Also, I don't know, like the deployment we did from the other side, I don't know if like here you can get more stable.
Hold on, just gonna pick this up and we'll figure it out.
No, this is gonna be.
Alright,
So, no.
yeah, hold on a second. Maybe we can stick it somewhere in that box. Or some door is not gonna nuisance. Push now.
Be sure. Okay.
You're gonna be in the holes there. Watch out a little more.
Please. Okay.
That's all we got.
All right.
That's gonna be the leader.
At least een vlette bocht dazwischen.
Von anderen Seiten muss da stabiler sein.
Maybe just much down, you know what I'm saying?
Very shallow.
Yeah, I'm trying to make it so that much straight down first, which you can get. Alright.
Oh, it's moving a bit.
Ah, yeah, that's very good.
Okay,
You
that's
can-
soft. That's good. That's
Okay.
decent.
So if you can try here to go even deeper in, just see how deep we can get the chisel in. Very good. You could also see that the rock is moving behind, so it's very good. This hole is good. They already went in like far like that, so I would continue to push down there. Yeah. Good.
This is shorter than longer.
And to anyone who's just joining us, you're watching live footage from ROV Sebastian, broadcasting from research vessel Falcor 2 of the Schmidt Ocean Institute. We are on the East Pacific Rise, off the coast of
well, we came from Costa Rica, but the closest landmass would be Mexico at this point. What you're seeing here is some basalt rock with some riftia tube worms, and we've just removed the mesh box that we had over there, if you've been watching along the last few days. And one of our ROV pilots is just making sure that there's space enough down into the hydrothermal vent beneath the rock here that we can fix our temperature probe and a hose to collect water samples from inside there. So we don't want to damage the probe or the nozzle for the hose and the pump. So Russ Coalfield is just making sure that we've got clearance in there. But we don't want to break the rock too much at this point. We're taking the measurements before we do some of the rock collection later on. So you can see the outline of the bacterial mat that's down there that was within that box. The mesh box was designed to allow seawater to flow through freely in and out. There we go.
Space there for the nozzle.
Yeah, and that whole rock is moving. That's great.
Is it possible that we just, I think maybe in this area it doesn't go really deeper, we don't know.
No, I can't really get much more than that.
Yeah, but my question is, would it be possible to leave this in there and try to stick the temperature, also the fine bag, you know, the small bag probe in there, next to it?
We can give it a shot.
Because if you take it out, it might crush back,
Yeah.
you know?
Yeah, it's not.
Yeah, it's not holding, but it is maybe holding the...
Let's just wait for it to settle.
Yeah, just let's wait. We have a lot of time, so we don't need to rush at all.
That's a big floor coming in there.
Oh yeah. Monica, would you be able to just tell our viewers what the purpose of collecting the water would be?
Yeah, sure. So after we removed the mesh box and sampled basically tried to sample the animals from the surface and took away the large ones, what we try now is to open this crack where the vent fluid comes out far enough so we can stick in the temperature probe, and next to the temperature probe there's a hose connected so we can sample water right from the subsurface. And we want to basically get the water from the inside of the cave. But we have to be careful because we don't want to destroy the temperature probe.
If we were to break the rock at this point,
We don't want to break it. We don't want to break it away because first of all it takes very long, and we would like to sample more the water that is in there because it's continuously flowing. But before we open everything to collect.
right. Thanks for that.
Yeah, maybe it's possible. Are you doing it right now to move it in the other direction? Yeah, like this. Maybe it holds.
I'm just trying to get there.
Yeah. Yeah. Yeah.
Come on, we'll try this back. Stay in the spot.
But it's how much are you in? Maybe 10 centimeters or?
No, maybe not as much. So.
Yeah. I mean, 5 centimeters.
We're almost outside of the area now, because this is the corner.
That's quite deep there.
Yeah.
Do you want to try and pry it here and take the temperature reading from the higher flow section? You see behind it, there's quite a...
Yeah, I think this area, I just wanted to suggest maybe we can look at be here, gell?
So I wasn't able to get much penetration now.
Okay. Yeah, we don't know how it looks underneath now.
It's probably.
Can I check a little bit the area behind first before you grab it? Just wait a little bit. I wait till it's clearing. Yeah, I mean it comes out here. It's like,
Yeah, it's quite a decent flow
I
there.
think this is. Did you try this area?
Yeah, it was kind of hard. We got down maybe a couple
Okay.
of centimeters.
Because here is it's here. It's the strongest. It's outside. Do you know if this is coming out or it is just laying there and the tube worm is stuck there? I don't know. I cannot remember. I think, yeah, I think it was stuck. Yeah. Let's try. It's harder, for sure harder over there, but could you try to, I mean, this is now just to grab the tube and move it away or pull it away or so. Maybe it works now because you loosened the rock, you know. Then we could see better.
Yeah, grab that up first. You get some try to grab it. Just try to grab it. Just try to grab it. Yeah. Grab that first, okay.
Yeah, it was like this much, I think, in it. I've got like this. Here it's deeper, no? Yeah.
Just not strong enough. too heavy for a building.
Hmm.
Pull it out. The worm, can you just pull the worm out?
Yeah, you can.
What's that, was it before you broke the rock?
If you put away the sizzle, pull it out here, then we can see a little bit better. I saw, yeah. Or with the other arm, is this?
I'll try it out, actually.
Yeah, and keep this one. Mm-hmm.
No, it's very tight. I don't know what's on in there. It doesn't work. Maybe I'll take the chisel this time.
Pizza.
French fry. Nice burger.
Sounds good.
Yeah.
Yeah, it's pretty good. We got pepperoni, margarita.
Do you guys put a special request in for?
So it's good. Good. Yeah.
Alright, so, what we're doing now,
I'm just gonna say, we're gonna try and take this out again. I would put it in a request for it. I feel like the boat's like listing this way today, Gil.
I don't know,
My shower this morning sure is. So
the plate is moving, but we try to pry it open with the sizzle a little bit more so we can stick in there the temperature probe with the sucking before we lift or we move further. That is the idea, but it seems not so easy because it's a very tight.
Yeah. It took a while last time.
Yeah.
Getting this out, make that go. And I put a chisel in the other arm just so we can get access to easier, in case I'm gonna lift it. But I'm trying to clear this area. This side here has got fairly deep.
Oh, you're getting it in there
It
now?
was in like maybe 5 centimeters or something. But I'm trying to get further up with the floors. See behind that rift here, there's a decent flow. That's where they want to control it. Yeah, so.
Here's the biggest.
Trying it out, it's,
Yeah.
it's in a divot on that. So getting out is going to be difficult. The old college dropout try.
nice one, Russ.
Thanks. Thanks, Ross.
Zach back.
Move the good part further.
If you had the big bar, we just flip it all over.
I don't think they want to flip
Yeah, yeah, not there, yeah.
Keep that.
First, you can't move these so it comes
The
out.
flipping would
Yeah,
be the
right.
next part.
Probably the next job. What are you doing right
So
now?
we're trying to pull as much of that rippia out right there as we can,
Pulling the roof again?
so that we can try to access what the
This is the
Flow
way it's
is.
blocking views. You had the chisel in here, so you can see the break there.
What roof?
Just walk it.
Hello. Have you pizza yet? Do you have your pizza yet?
It's a junk food day.
What's the
I haven't had it.
Yeah.
Is it the Turkish pizza?
It's not like thin crust, but it's like they got pepperoni is pretty good, they got 4 cheese is pretty good.
So I was just wondering, how long do you estimate before you go?
I don't know if we're gonna today.
No?
I'm gonna talk to that lady right there. I don't know what the plan is. I think we're gonna do some water sampling here.
I'd say between 47 to 48 minutes.
Maybe longer.
Definitely not just pulling that number out of my butt.
Okay.
Do you think when you come today you're gonna try to flip the rock like you did last time or not really?
I don't know.
You don't know?
Yeah, yes, we want to have something, but I'm not sure if I want to recover a big rock again. I want to flip it if it's possible, or just break pieces and take it in pieces,
Okay.
because it's almost impossible also to look at it. But first we want to get that.
So you're gonna keep digging for a while.
Yeah, I think so. I cannot give you a good estimate. This is very difficult to
No,
say.
no problem. No problem.
Yeah.
Thank you.
Yeah.
Okay, I'll be back in 48 minutes.
Thanks for the warning.
What's that? Just hit you up.
Sorry. Nothing too crazy with cheese with it, that sucks.
Oh yeah. That would.
I'm so sorry. So sorry.
Alright, so
I just dropped this guy or what?
If you can, also you can drop it there, yeah, because we have the bio box closed, so it's okay. I have the other part. Just drop it,
it's
yeah.
gonna float right back in there.
Okay.
Okay.
Yeah.
Alright, so
Then here,
next thing we're gonna do is we're gonna try to make sure that there's enough room,
tell me here.
ideally right where the flow is, right there.
Well, how about I stick this chisel in there to
That's
see?
that's the plan.
Right.
We're gonna put the chisel in there and see if it's capable of taking the temperature probe and the log.
My crazy idea was is that the chisel will hold it open a little bit before we crush the other thing.
That's possible.
But I don't know if this is possible.
Make sure to check the earth.
Question age.
Want me to take one of those? Jackie?
Alright, the bridge.
Harvey?
And I'm gonna come around like 20 degrees to starboard.
Alright, copy that, I'll put it in for you.
North, you're out of the room north. So it's otherwise it's red dot. Brush it.
I've got that waypoint, thanks.
And you?
Put it in there for you or what?
Yeah, it don't have to be perfect, I'm just gonna, it don't have to be
There. Do you want a sideways graph?
yeah, vertebrate. Good work. That's cool. And a little deeper.
right now. There. Straight below here. Right below the ground. That's a good spot. Not there. Wait, that's on our line. Traces definitely doesn't run so I can put this.
You started that again?
How deep in there do you want this probe to go?
I don't want to say it as deep as you can, but
I think we might have to widen it a little bit now and then, because it's like, we get it in there, but it ain't very deep, you know?
yeah, okay, then let's just see.
Rotate that chisel for you.
We'll try turning it real quick and see if it's better then. I think we'll do this.
Just go down back a little bit lower and I'll just spin the tip of it for the key of it above you.
Right there. Yeah, close, and I'm gonna open my jaw a little bit, or you know, leave it.
Probably just.
But
Oh, yeah.
perfect. Make it hiding from the now because now the one is outside the color of this one. You see?
Little team spirit.
They're stained. There are two stained ones.
Don't get much in there. Give me to try and kind of drill it out a little bit?
Yeah, if you can.
Is it a little bigger, a little bit down from there?
Hmm?
It's like.
Yeah, it's all moving. Yeah.
I think I just put a little chunk.
But it's so close to the edge, you're hoping to keep it within the same clear. Fluid coming out, that's for sure.
Can you guys turn this hot water off so you can see a little better?
Yeah.
Get that out of there. Won't get.
Ah, it's actually coming out hot here also.
Yeah.
Yeah. Yeah, this is. Yeah. This.
So now I'll try and go in here. That's not too bad there.
No, I think it's good here also. Yeah.
So go for it.
Hmm.
With the probe.
How deep are you? Yeah. This-
Just the end.
Yeah, it's like this, you know.
So,
Like, but this
2
thing.
inches.
Yeah, better than.
It's not bad.
No, it's not bad. It's just that also the empty tube here is in a way to see really.
Is that more than just the tip or is it just the tip that's going?
Yeah, on the other hand, it comes out there, you know.
Let's say it's about 4.5 centimeters.
Okay. If you can shift this tube in here, you can.
Scoot them out.
Yeah.
Grab in, I guess, but you definitely do that. All right. Pass this to you. Go over the problem.
Mm-hmm.
This is going to be the Capri Sun, right? Yeah. All right, so I think that's you, huh, Carl? It is, but that's just that. Way. Take this right around if you want.
Set out the porch out.
Yep.
Just do that. Like it?
Okay, this way or should I go straight off? More motion from the background right there.
Bewegt sich und uns wunschlos.
Ist jetzt so.
Aber du kannst den schießen, du kannst nicht dabei lösen.
Ja, das geht's nicht, ja.
Sonst machst du es hin. Also ungefähr so viel Glück oder nicht. Aber es kommt jetzt über euch Haus raus. Was nicht. Weißt du, die Zeit zu einstellen dann. Ich schaue mir das jetzt genau an.
Der da.
Da ist aber der Prater jetzt. Und das, schauen wir mal, let's check the temperature.
to keep my camera down and
So this is the ancient model. It's drifting.
Could we put on the temperature sensor that we can see what's the...
probe.
What do you think about me dropping this, and then that way it'll automatically go as far as it can go without breaking anything?
You can try, yes. Yeah. Mhm.
And I'll let go.
a little bit of spring there, guys.
That way I can kind of jiggle it and see
Mhm,
how far
very
it goes
good.
without actually smashing it in there.
Mhm.
Can we get the tip?
It's in there pretty good. All the white tape is gone.
Yeah.
Let's see what it shows.
I get it here in one call.
It's 24.3.
Mhm.
Ja. Ja, gut.
Before it was like 10 degrees on the surface when we measured it, like when we applied the
it
mesh
is
box.
so.
So that's
24, pretty good.
23.
Super.
So we take here the sample?
Yeah. I
Yes.
would say.
So we can start the pump.
Okay, I'm gonna go ahead and start the pump then. Everybody's ready?
Yes.
You know, what are we timing this for?
1 hour 30.
Isn't that what blew that up yesterday?
1 hour, 40 minutes.
Yeah, yesterday it was like 1:45, I think.
But did it break because it
Yeah.
broke? Because it's 10 liters.
Yeah.
So, well, then let's do 10,
1:15.
1 hour 15.
1 hour 15.
So started at basically noon.
So-
58.
So 1 hour 15. Good.
And the temperature is
24.
0.6 the maximum.
Okay.
1 hour and 15 minutes.
170.
Yes.
Yeah, that's good. I mean,
Okay. Water sample, small bag.
I'll watch this. Okay.
Mm-hmm.
So this is 12, 1:15.
Mm-hmm. At 1:15. Yeah. Good night.
Ja, ich habe gemerkt, wenn ich nicht da bin,
Ja.
habe ich so das Gefühl. Aber das ist die ganze Platte, das Schiff.
Ja, mussten aufrufen. Ja.
Also,
So the plate shifted in this direction, I thought. Yeah.
das hat sich nicht beide bewegt, ehrlich gesagt.
Ja.
Ich meine, ich wäre froh, wenn wir es nicht mitnehmen müssen und dass das Stücke sind. Aber
Muss
umso
man
ist
schauen.
natürlich auch gut,
Ja,
aber das
ja.
kannst du nicht so.
Muss man
Also
schauen.
wir machen dann, was wir machen.
Genau. Ja.
Eine Minute kommt sicher um 2 spätestens
Mhm.
wieder. Also das ist eben probieren nur noch.
Ja. Mhm.
Okay.
Okay, good. So.
Thoughts could be in here breaking rocks and all kinds of stuff.
Now you have to wait. Huh? Another hour waiting.
How'd that box come up pretty easy? That box came up pretty easy?
Yeah, it was good. Yeah, yeah.
But not to like pry it too much or anything.
For how long will the sample?
1 hour 15.
1 hour, half an hour less than yesterday.
Yes.
An hour 50 or 15?
15.
15. Okay. That's right.
Just in time to repair it.
Sorry, I should have said that.
So the breaking party starts in 1 hour 15.
Yes, adventure.
Yeah, we could do the science stuff around it, but I don't know if we can do that.
It's for you.
So, everything that is here, we don't need to log, including this sample.
Okay.
Understood. 170. I told him yesterday the same thing. He said and logged.
So listen, Salva.
All good. How's the junk food? It says good.
Okay.
Okay, see you soon.
Never needed to turn to starboard, so I moved back on. It's at 20 degrees, so I think it wound up right once they made the change.
straight things?
It's torque stripe. Torque stripe. So whenever you torque a bolt, if you want to monitor it, you can put this torque stripe, and it's really brittle. And so if that moves at all, it cracks the torque stripe, and then you know
Oh,
the
it's
bolt is
like a,
moved.
yeah, yeah. It's called torch.
Torque stripe.
Torque stripe. And use it just at the places where you know it's like dangerous that they are.
I'm sorry?
You only use it at the places where you know it's kind of getting.
So we did do all of them at one time. We were just doing our rebuild of the arm, and so everything was new, and so it was all torqued. But since then, we've done maintenance of the arm, so some of those have been removed. So that's how you can tell. See that plate no longer has any torque stripe on it. That's because we've removed that. So and see one where it's got just a little.
Like here, the one, this one.
Yeah, it has just a tiny bit. But those three there have not, so we've not removed that since the rebuild. So as those. Yeah, so at one time all of them had it.
Yeah. And then you open up the entire arm, or how do you maintain the arm?
There's different parts. So there's these wireway covers basically. So all the electronics inside have covers, and then so you can get into there and still operate the arm. Still has hydraulics, and then there's other plates that have built-in slip rings into each joint. So if you remove those, obviously you'll be in the main hydraulics. You can't operate, but yeah. So you can get into the arm. You can also basically remove sections of the arm. So each joint has a resolver, which is giving its position, and this is telling it what position the arm needs to be in. That's how it controls the arm. But if you remove the wires from those resolvers into the midsection of the arm, then you have the ability to remove basically 3 sections of this arm and separate them and take them and set them on a bench or whatever, do more work.
Is it watertight inside there?
It's oil filled, compensated. So yeah, no air.
And what oil is it used?
It depends on the system, but I think typically we use, it's called TELUS 32. I think we're actually using 20 here. The 2032. I've heard both. I think we're using, it's something similar to TELUS 32.
So it's mineral oil.
Yeah, it's basically, yeah, environmentally safe. Essentially.
And do you think it's correct to use the term robot for Sebastian? Because for me, robot is kind of autonomous. Or is I'm wrong, and robotics is also even when it's human operated?
I think it is, yeah. I mean, autonomous, you're probably better at this because you're the engineering side of that. Do you have anything to say about that?
For most of Schilling's tenure, they kind of considered this telerobotics because there's still some local processing happening subsea. So although the high level decision making is happening up here when you're giving inputs, there's still arm itself has to do some really basic controls to do what it's told. I think now more people are talking about it in terms that you're kind of suggesting where robotics would have somewhat more, I wouldn't say autonomy, but just, I guess, autonomous functioning is a good way to.
Yeah, I think it's also from the science fiction literature, a bit different from the word used in the science fiction literature than what is used in engineering.
Yeah.
I think those are two different communities using the same word.
I mean, I get what you're saying, because nobody would say that a backhoe would be a robot. Nobody would say that, I don't think, right?
Yeah.
No, it's equipment. So yeah, I mean, it's a point, good point, I guess.
So this is like more, that's not like, I don't think I've ever heard people talk about the sub as a robot typically, as much as like a remotely operated vehicle, same as like a remotely operated crane or anything else. The arms just look robotic, so people will sometimes say that. There are some subsea technologies that are legitimately robotic.
I see it as an exoskeleton. The whole thing of Falcon 2 with Sebastian, kind of an exoskeleton in a really massive way.
Yeah.
The giant exoskeleton, 2.5 kilometers, like tentacle.
So the other thing we could think about, and this arm is capable of it, it's just different software, is Schilling has also created it's basically an array of cameras, or light sensors, whatever you want to call them, and have you ever noticed, like when we pull a probe out of a tube, like if it's not perfect, it'll side load a little bit and then it'll pop out. That's because of a little bit of human error, you know, like it's almost impossible to just draw it out perfectly unless it's programmed to do that. So these light sensors are basically sensing panels, and like especially in the oil and gas industry, we have it's called a hot stab. So it's basically a long tube like these that insert into a shaft. And that's a common thing when we go to pull them out, like sometimes they bind, and because it's such a tight fit, they have to seal hydraulic fluid. If you don't have it perfectly aligned, it's very hard to pull. And we have tricks to do that, but what they've done is they've programmed the software to analyze the face of that, and it will correct the joints and align it perfectly. So I can still move it up, down, left, and right, but the angle being off, it will fight you, and it'll make it go that way. And so then all you do is just align it, push, and it goes in perfectly every time. So there's still a lot of autonomy. We don't use much of it on this one because nothing is the same. It's all biological, right? So like we can't take advantage of any of that kind of stuff. But RVs, as an industry, is using a lot of that kind of stuff.
Assisted.
Yeah, assisted and just taking the human error out of certain things.
But you keep the control on activating this feature or deactivating.
Yeah, you can deactivate that.
So we use very like panel one stuff that they were working on with T4. That used to,
I believe so, yeah. I believe you can turn that off.
Yeah, some of the technology that's being applied now is kind of, you're still letting the human choose like at different levels what the task is and when to execute the task, and to some degree how, but like he's describing like some of the stuff you're not really good at.
Yeah.
Just offloading that, and some of that has to do with like force sensing manipulators as well as machine vision manipulators that lets it interact with the world, having sensory feedback that we don't have. So like if we told it to go, like there's some technologies now, like the arms on these, but if you try to push them into something, it would like feel those forces and accommodate for them rather than just like trying to accomplish the position. Yeah.
But you would not have access to the code. This is proprietary. When you are using these assisted features, the company has their own So you are not involved in the.
I would say, so actually, a lot of the new technology, so I was involved in 2 projects that use that technology. The first one was completely proprietary, and it worked, a lot of development overhead. The second one was based on a software, it's open source called Robot Operating System, ROS. And ROS lets you incorporate force feedback and vision feedback into kinematic models now. And this is a completely open source software. And there's open source software for like ROVs, other types of robotic arms, and AUVs. So it's actually not proprietary anymore. Like the implementation of it sometimes might be, but you can, if the software is open source, you can just open it up and see how they did their reverse kinematics and, weighted different parameters and so forth.
All right.
Cool.
Yeah, that's good. Like when this was originally developed, and like the ancestor of this was developed in 1985. And back then, what this was doing was just like completely mind-blowing. Everything was completely unique and proprietary. And now if you wanted to recreate the movements, not necessarily the mechanics of its arm are just incredible, but just the software to move it, it's just completely open source. Now a lot of kids in high school are doing this in their robotics programs.
And is there an equivalent in hardware? Are there also open hardware?
No, so that's where, not for this sort of stuff. Like you can take this arm apart and you can figure out, try to see oh, this is how it works, but there's been multiple people that have tried to replicate this, and it's just, they either can't or they realize it's not worth it. There's a bunch of really, really interesting and difficult things from a manufacturing and material standpoint that are just kind of not worth copying, I suppose.
Yeah.
Like the plate he was talking about with that torch right here, that's about they're 14, 15 millimeters thick. That starts off as 3 pieces of titanium, and it gets machined in all these hydraulic passages, machined first, and then it goes in an autoclave, gets cleaned, goes in an autoclave, and pressed and heated up, and they actually grow the titanium crystals back together, and then they machine it again. So that's how they are able to get from underneath those bolts right there. There's a bunch of holes coming in that are going through kind of like a maze of hydraulic passages to the very center where they connect to a slip ring. And you can do this with 3D printing, but the material strength and it's like that's not quite there yet.
Yeah.
Although 3D printing is being used in this sort of application as well. So it's pretty
It's crazy.
Yeah, Schilling's amazing. So they're also working on, I've heard of it, I've never seen it personally, but this is what's called a free flyer RV. So it goes all the way to the docking head, as you guys have seen, but the kind of more common RV has a TMS, tether management system, and so it's basically either a top hat or a garage type where it backs in. But either way, they've developed software or developing software to where they have an auto docking feature. So it's a common thing for pilots when they return to that TMS to turn around backwards. They use that docking camera right there, and they fly into there. So it's like a little target. It's not that hard to do, but things can go bad, and when they do, usually it's actually really bad. But so yeah, they're trying to take the human error out of that, and you just get close to it, hit a button, and it just flies in there for you. I don't like that because I like my job, and I actually
Takes the fun
enjoy
away.
the talent part of flying.
Yeah,
Like that's fun for me. I like being good at operating, so I don't like that. But it is a cool technology, and essentially the RV's flying itself. And even this one will do that to a degree. Like we could come up, set an altitude and a heading, and dial in. Like I want you to go 100 meters, and it'll just go and stop at 100 meters. even this one, it'll do it.
But like not in this area, I guess.
Yeah.
Because like all the AOVs, at least like the one for science, they still cannot manage to operate in such in such a terrain. So they
Well,
can operate like on above with the planes. That's all no problem. But they crash then against the.
True. You would still have to manage it because this wouldn't see a wall necessarily and stop. So yeah, you're right about that. But what you're saying is like it would be on auto altitude. So with this kind of terrain, it would be diving up and down, which this could do to a degree, but it would be difficult if you were anywhere close to the bottom. But what you could do is just do auto depth and be above that, and then you could 100% do it. It would just stay at a depth, and then you program.
Like also with all these small features that we see here, like all the spires, the.
Yeah, as long as you were above them, you'd be fine. But would it fly around them? No.
No.
Yeah, the type of collision avoidance type stuff you see in like commercial, like hobbyists, even like drones and whatnot, hasn't made its way subsea. And part of that is the sensor technology isn't as good in terms of like, so you can still get really nice like high quality sonars and things like that, but when you compare them to like LiDAR and like terrestrial, like atmospheric LiDAR and machine vision, the depth of field and the resolution and data rate you can get lets you do like really good mapping. They call it simultaneous locating and mapping as far as like navigation goes. So you can do obstacle points and things like that. Subsea, like I've got to think there's people trying to figure it out. And the software certainly it's all open source, but it's not been something that that's made its way out as commercially into ROVs. And I think part of it is because I worked on one of the projects I worked on at Chilling was kind of attempting to replace people, or at least like the skill level in people, and all that ended up happening after I probably shouldn't say how much the development was and how long it took, but a lot of money and a lot of years of development basically just created a bunch of technologies that enabled people to do things that they weren't able to do before, but you still couldn't get away from the fact that you needed really skilled people that couldn't, because operating in the ocean from a vessel in this environment.
Yeah, but there's no way that a robot could do this,
Well, yeah, it's because you're relying.
Because you're always like also changing plans. You're kind of you need this, what we communicate. It's like not this you cannot I don't know.
And it's not just that too. It's also like the technology, like the equipment is just not as robust, and it requires so much human intervention to accommodate for changes in system performance and behaviors as things wear or things get hot or things just change. And so you still end up needing, you're still like, no matter that know all about like electronics, fiber optics, high power, like handling, like winch handling systems and like hydraulics, all this stuff. And so you may have solved like the tasks that you see out of the cameras, but there's so much other stuff going on that like hopefully you made that one or two things easier. Then you still need those exact same people, even more skilled people, because they have to be solving all the other problems that weren't foreseeable. And not to say that they couldn't get there someday.
Well, the other reason I don't think it's probably ever going to happen in this type of RV environment is what's the gain? Like these things go so slow. Like there's no performance gain for us to do RV work faster.
No.
Because we're needing data. We need to spend time reviewing that data. And so like things like this happen where we just said, so like an environment where you're building cars and autonomy makes a whole lot of sense because you can speed the process up and saves the company money, and it can do it faster and better than a person with the exact same arm. Imagine him trying to pick up a panel and put it on a car. It would just go bad, right? And it would be very slow. That's not really beneficial in this type of world. So I don't know that anybody would even waste the time to try and fully autonomize an RV and make it like super proficient and fast. What's the gain? So little that it's just not worth it. I don't think it'll ever happen.
No, I agree with that.
Maybe AUVs to a degree, but not RVs.
Going back to something you mentioned earlier, is that even with as much money as that Schmidt spent on development project to try to de-skill or reduce the need for as many operators and whatnot, the only way that that could even be commercially viable is if not, you can't just change the ROV, you also have to change the subsea equipment. So that means all the manifolds and jumpers and panels and pipeline termination. Everything else has to change, whereas we don't have any control over the environment. So
doesn't make
it's
any
like
sense.
you could spend hundreds of millions of dollars trying to automate this, and you would never.
No, you would never get the same.
It
Yeah.
wouldn't be worth it. You'd still have to intervene. Whereas I suppose in construction, there's some things you could do. Like for example, with machine vision, one thing that Trillium does is they use like QR codes for position and orientation with the manipulators. So on the camera on the wrist, one of the couple of the manipulators can read QR codes, but not just for like reading data. It also knows once it sees it, if it knows where that is, it can orient itself relative to it.
Okay.
So that's useful for
Yeah.
like a piece of equipment,
Yeah.
because then you can put this calibrated location,
Then
and then it can use that. And that's actually happens in manufacturing too. We use the same thing for orientation for robots. Where subsea, it's like these RIFT aren't exactly growing like calibrated QR codes for us to grab onto them all the time.
Yeah, I think there's a moment of. I think it's a long time. It's actually the whole 20th century, the dream of having the robots doing this stuff, and the promise of making the autonomous thing fully autonomous. And now with the ChatGPT, there's a hot moment now with the audience, the society awareness about this. But I think it's not real. You see here the complexity of life, and even the complexity of geology. Like we don't have this capability to automatize the stuff, not even with the robots.
Right?
It's hard to tell. It's so slow.
This was before.
You know something?
So we're pumping now 40 minutes, which should be 2 liters and a bit.
First, we don't
No,
think so.
no. So you can see that's like the first picture, and it looks exactly the same. It's probably
So look at this line
Yeah.
on the bottom of the white. There's a line that goes here. It now is more pointed. Does that mean it went up?
Which one?
The line here. See the.
Ah, yeah. That could
But
be.
see how this goes up now. It's a little
Yes,
different,
it's-
right?
Yeah.
It doesn't
That's
look bigger,
no-
but it
but
is
it's
a
like
difference.
Yeah.
Yeah, before it was
like this
flat,
is like
now
up.
it's more up.
That this one moved.
Yeah. I don't know. I don't know if that's the bag or what. It's kind of hard to say. You know, it almost looks like in this one, like the bag was compressed, and now it's
like
like maybe it's expanded this way. It's really hard to say, but I almost think it may be worth just finishing the timeout.
Yeah, yeah. This was some movement, because yeah,
There's definitely some movement.
yeah. Ah, these bags drive me insane. You can get a different angle before, like more like this, with the camera.
Maybe. See if I can make that exact image. Right there. It's close to your,
Yeah, yeah.
but that looks like a
It's
steeper
steeper,
angle.
yeah.
Oh, I think something's moving.
Let's wait.
So we are pumping.
Hmm?
It is pumping.
Probably.
Probably pumping.
Look at Salvador.
Hmm?
He's in space.
So the chef doesn't have problems with pineapples on pizza. That's good to know. I use his as an argument because I like it.
Okay.
Don't tell any Italian.
Yeah. Yeah, but it's good. I like it. Figs on pizza is also good.
Was it figs on pizza?
No, I like, for example,
okay.
figs on like blue cheese. I think it's also
Oh,
a good
no.
combination.
So, the pump is on, yes.
Sensors on.
And is there a reason that you only have a line for operating additional stuff? Or could you add more?
One line.
These 12 volts line that it's you can actuate the pump from here.
Mhm.
Could be more of those lines be added?
Oh yeah, yeah, we have plenty. So on the science there, we have relays for what, 8 more that we're not even using yet, and then you also could have AC voltage on like the light box. Yeah, we have a lot of options for more equipment. Much more.
Is it a lot used by
It's not
scientists?
used now on other cruises with more demanding sensor integration with the RV. Then yeah, we use a lot more of them, but yeah, we're using very minimal on this particular cruise. We have basically this pump. I think that's it. I mean, other than our
ISMS,
sensors, but
Yeah.
the other pump's battery operated, so not really. It's just not being used this time.
But what kind of instruments would be collected? Like ISMS, if it would work. But like what else? Like more sensors, more temperature sensors, or what is
For these
usually,
channels?
Yeah, what is usually used?
Seems like it always changes. You know, like we've had mass specs before, so those are obviously powered, and the data's running through these channels. What else are we running? I'm sort of new to the science side, of it, so I'm used to oil and gas RVs, but what did we use last time? We had the mass spec.
I was probably talking about octopus cruise or coral cruise when we used Solaris.
I think it was the coral cruise that we had the mass spec. Yeah, it was.
That was the reason the reactive ocean sensor species protection. That one. Probably used mass spec on the first cruise though.
Yeah, the coral cruise.
The word hydrothermal one. The mid-Atlantic ridge one, I'm sure you did.
Oh yeah, that might be right. Forgotten what everything we did on that cruise. Yeah, I don't remember what we had integrated.
Yeah, the coral cruise, we just had the reactive oxygen sensor and the DNA sample.
Oh, that's right. What was that called? That was
Solaris.
Solaris. That's right. So yeah, we they were looking for
Reactive oxygen species that are supposed to be stress indicators potentially for sponges and corals.
yeah. So like instead of thinking that the current's just blowing it through a coral, they were trying to see if the coral was actually basically breathing and sucking it through, and they were using that to find that out.
That sounds obviously reactive oxygen is reactive. They were trying to measure it in situ and got directly up the coral with those numbers.
They didn't find a whole lot, to be honest, with the coral, but surprisingly, the sponges did. Like,
They suck it in a lot.
yeah,
But
they
that's
bring
the,
a lot of
yeah.
volume of water through.
Yeah. Yeah, the sponges are cleaning our ocean.
And do the mining people use explosives underwater for the rocks?
I've never been around mining. I'm not too sure.
I've never seen the mining they're talking about for the bridges, only for the abyssal plains. And that they're just scooping up the surfaces, or they're sucking up the surfaces of it. But I don't know about this.
But
I
not
don't
that
know explosives.
anybody would use
Well, the nodules, I think, just sitting on the surface, or like in the first layer of mud. or sediment.
Yeah.
I hope not.
Like the machines they develop for like potential mining of sulfides, it's basically big caterpillars that have like huge, they just crashed the rock.
Yeah, we could, yeah.
Like those ditch digging machines.
Yeah, massive.
Yeah. And for the nodules, they inject basically water to lift up the nodules with the sediment.
It's like almost like trenching,
Yeah.
just sideways.
And the hydraulic hammer thing, this cannot be used either, like the land ones.
No, it is. I know like some geologists from Germany have used it to get the rocks from the,
I used one time, once again, oil and gas. I forget what it's for. And we commonly will use like an impact wrench, which is kind of similar operationally, I guess, subsea. They're really hard on these arms. These things like should honestly be kind of protected. They're really precision. I mean, they are strong, don't get me wrong, but there are way stronger arms out there, but they're not as dexterous as this. So like it's better to use a sub that has that kind of an arm. It's just kind of dumber, but really strong to use that. I would not like to use any type of jackhammer with these. You agree, Alex?
Yeah, you should use jackhammer.
Yeah.
I've also seen like, not for harvesting, but for sampling, you guys, like the same quarry drills you use in science, like to core out samples from stuff like this, formations and minerals. Like using coring drills. It's not for harvesting minerals, but for just like trying to get mineral profiles in rock formations.
Yeah, I think that, yeah.
So this is like spinning.
Yeah, and it's just like any other quarry drill, just like where you get like a cylinder.
Yeah.
Same. But that wasn't for any like commercial, that was for like more exploration and exploitation, I suppose.
And this could be operated here?
No, it's like its own.
It's like a own ship, it's decided ship. It's like sampling all over the world, and getting sediment cores like from.
But it goes to raw.
Yeah, it's basically a big
Drill.
drill, but the core that has a, I don't know the technical term for it. But
Correct.
yeah.
No, because these...
Like also like on land, we also do the same. You know, you have these machines that, and then you basically load another liner. And a liner goes down.
Well,
and you bring it up, and the next one.
Well drilling.
Yeah. I'm not so convinced about this bag.
It's not working.
Hmm?
It's not working.
I don't think so, to be honest.
Salvador.
Another programming feature would be to have differential image that you can overlay the one 30 minutes ago.
Oh, that'd be cool.
Yeah. Let's see the movement. I was thinking yesterday to bring a whiteboard marker and
Yeah.
pen it.
Oh
You know
my
that,
god, that'd be amazing. Just use a Sharpie. Have you ever worked with any of the hydrophones that they use, like on some, like subsea, like on RVs?
Not so. I was like once in a project not so long time ago where we put hydrophones like at hydrothermal vents at different distances to record the sounds.
Yeah.
But then we just we deployed the hydrophones with the ROV basically.
So what does a hydrothermal vent sound like? Really?
Yeah.
That's cool. I've seen I've never been offshore with it. I've just been told about like some
It has a
hydrophones.
very low frequency sound.
Yeah, and I'd love to hear like some of those sounds because I know that I've heard of RVs deploying them and they filter out the sound of the RV. They go up mid-water, get a baseline of the RV, filter out the sound, and then you can kind of
Yeah.
pick it up.
There's like one. So right now this publication should be written in the next couple of months actually. So we have data from hydrothermal vents from the Rainbow vent Mid-Atlantic Ridge and from vents north of Iceland.
Yeah.
We recorded the sounds and actually the student is he's finished but still the paper needs to be written.
Oh, that's cool.
But yeah.
What do you know what? Like I guess what type of was that on an RV or was it just on a lander or how did they deploy?
We had different things. So in one expedition we had a ROV with us and then we deployed like one at the vent 10 meters away and 200 meters away to kind of get this, because they need like 3 different points to get the, also the true soundscape basically. And another time we mounted a hydrophone on a, it's called hopper. It's like an instrument that Muse built to basically fly like a camera that's dragged and flies over, and then we basically towed the camera from off vent towards the vent and through also the black smoke basically, and the hydrophone would record the sounds. And would also have like deployed like one mooring with a hydrophone on it.
Yeah, that's cool.
To get this, it's yeah.
That's awesome.
And a couple of years ago, but it's a long time ago, also like here was once a hydrophone deployed, and this study is published.
Huh. Like that would be such an interesting thing. Like imagine right now, like we just have the sound of whatever, like stick it like near the vent so you can hear it as it's playing.
But it's really like a very low frequency sound, like really, as you, I don't know, And then you would hear probably some clicks of crabs and things like that.
Oh, that's cool.
Yeah. And we don't know yet like the function of the sounds. So like on in shallow water environments, like the mussels, for example, they use the sounds that the waves produce when they clash on the coast. They use this as a trigger to know where they have to settle.
Wow.
And and we have here like this Patimodilus, all the mussels we have, the most relative ones are from shallow coasts.
Really?
Mm-hmm. So these type of mussels you do not find like in abyssal plains, but the most relative ones you find on rocky shores. So, and it's not known, it's also one of the things we want to test like in the future potentially. So if they need the sound of the vents to know where to go down, because this is still not known, like how the species know where, when to come down basically again and settle at the next vent.
So when you say, I don't know very much about the life cycle at all of a mussel, so when you say need to come down, is that like right after they spawn or whatever it is? Like, is it a larva?
It's a larva, and there are several, larval duration. It can be like a couple of days to a couple of weeks, depending on species. And this time, basically, they can stay in the water column. We also know that, for example, this Rumincaris shrimp from Mid-Atlantic Ridge, it travels really high in the water column, like really like not in the deep sea, but high up.
Yeah.
So also this larva use different these depths where they let them disperse.
So these larvae are floating around in the water column, moving with the currents.
Yes.
And they're listening, potentially.
Potentially, this we don't know, but could be.
The idea is that, and then how do they influence, like, oh, I need to go down towards the
sound?
This
is like, something we don't know. Like it could be
can
like.
They swim? Like, or.
Yes and no. So they are.
Control their buoyancy.
Yes, and also depends on how old or young they are, and of course, like a tiny little larva cannot swim against the current. Of course not. It's like not doable. But like what basically triggers the settlement is not known. It could be chemical cues, like because you measure like when we do like CTDs in the water column, and you basically get a signal that the hydrothermal flow is somewhere. So it could be chemical cues, but it could be sound cues, could be by chance. you know, that they are just put out so many, and but this is something we simply have no idea.
But, okay, and so that, and the mussels that grow in like the abyssal plains are adapted to a different
Yeah,
temperature
they are
range
not
or
growing
different-
there because on the abyssal plains it's mud, so you do not find this. Yeah, you do not find them.
So what do the mussels look like there?
Yeah, it would be really tiny ones and different,
Okay.
totally different families, and
And is that because there's less nutrients available that they would not get as large? Or?
yeah, so we don't really know, like, you know, how the evolution of this vent species is.
Yeah.
But the most relative ones come from the shallow waters. And also when we look, for example, at the copperpods, the small crustaceans,
Yes.
the genera that we find in there are the same as that we once find on the rocky shores, associated with algae.
Really?
So what is also one of the projects I'm currently doing is a study like hydrothermal vents in Iceland, where you have like basically a transition from very shallow ones towards the deep ones to see how the community changes along a depth gradient.
So if it seems like would that be considered like? Okay. So aside from the bacteria, but then Riftia is unique to here.
Mm-hmm. Yes.
right?
Yeah.
So you have all these other organisms that are not unique. Yes,
No, they are like so there's a difference between the macrofauna and the myrofauna. So the larger animals, like also many are endemic, like even on family level.
Yeah.
On species level, like basically all of them are endemic to this environment.
Yeah.
When we look to the smaller size classes, so we find the same genera, but not the same species.
Okay.
So when you look at the species name, those has like two names.
Yeah.
The first one is the genus, the second is the species.
Yeah.
And you would basically find the same genus of copperpods, for example, in shallow waters, rocky shores, and here.
Okay.
But also, probably this also has to do with size and how much energy they need.
Yeah.
So like one theory that we have is that because the animals, are adapted to a lot of food also, so they basically need to stay there, and like over evolutionary time scales, they probably get more and more endemic,
Yeah.
and the larger they get basically,
Yeah.
because they simply need the food,
Yeah.
Yeah.
So the food they're eating here is going to be different than the food they're eating shallow.
Yeah.
So does that impact the way that did you want to swap over?
Whatever you want.
Well, yeah. So the if they're eating like foods that have different concentrations of different micronutrients or minerals or whatever it is, does it change the structure of biology at all of like these mussels, for example? Like would it change how they grow or like what organs?
Yeah, and also like these ones, the Spathodilus mussels, they have like a dual symbiosis. So they have metanotroph and so metagenesis, and they can also use sulfite, and they can also feed. So they kind of have three different ways of getting food.
Wait, so they have two symbiotic. So are those bacteria?
Yes.
So they
Yeah.
have two symbiotic bacteria that produce things that they can process.
Sugars for the host. Yeah.
And then also they can filter.
Yes.
That's pretty
So they are superstars.
Okay.
Or very, they can, yeah.
Is that true for mussels in coastal areas as well? Or?
So there are also mussels that have symbionts in coastal areas, but that's a different family again, the Luxinidae. Like the Mytilus, like it's the mussel that you also know from eating, that this doesn't have symbionts.
Really? So those are just only filter feeders?
Mm-hmm. Yeah. What's also interesting is that all this process of symbiosis was actually discovered at hydrothermal vents, and only afterwards recognized it's also present, in basically in tidal flats, where you also have a lot of degradation of biomass and also sulfur production. And also then basically we found out there's also symbiosis there, like in front of our nose.
Right, so they can get...
But it needed basically this discovery to find out the other things.
So in the shallow water, in the tidal plains and whatnot, that's like H2S from decomposing?
So not on rocky shores, but at the tidal flats.
Yeah.
Like where we have very fine, so where we have mud basically.
Yeah.
A lot of organic material that's also reduced, and by this process you also get sulfite, and the sulfite can be then used again by bacteria.
Oh, okay. So the sulfite...
That's a similar process than here actually, just that the source is very different. So the source on land is basically from a decaying process, and here the source is the vent flow.
Yeah, directly from the minerals and rocks.
Yeah.
Wow.
get there was saying we only see what we know.
Yes, that's totally correct. I think. This bag isn't doing it.
So it's the top of the hour here, a little bit after. Quick recap of what we're doing. So these are live images from ROV Sebastian, 2.5 kilometers below the surface of the Pacific Ocean. That is Schmidt Ocean Institute's remotely operated vehicle. And we, the voices you hear in the control room of our research vessel Falcor 2. This is the Underworld of Hydrothermal Vents expedition out here on the East Pacific Rise, about 1,000 kilometers south of Mexico, 2,000 kilometers west of Costa Rica. And today the team has gone back to experiment site 2, taking that mesh box off, seeing what they see, and doing some sampling. So Sabine, would you mind giving us a little recap of what's happened here today?
Yes, so today we're on experimental site number 2, and we recovered the mesh box today. So this, how we do this, basically first we want to get out the fluids from inside the mesh box, so we use basically a large needle that's pushing through the mesh, and then we suck out the water that's in the mesh box. And afterwards the mesh box is put aside. We also suck out the bacteria that basically had grown in the meantime inside the mesh box. Then we cleaned the surface area from the experimental site. Afterwards we tried to dig a little hole inside so we can put in now the pump that's currently or should pump water in, hopefully, from the subsurface. We also measure temperatures today of 24 degrees on average, and which is 15 degrees warmer than what we have measured when we would deploy the mesh box. So basically what you see is that the vent fluids that are down in this, we will see them when we start breaking the rock cave, is like hotter, in this case 24 degrees Celsius, whilst when we measured like the base of the tube bombs on the surface, it was like 10 degrees, which, you know, because you have immediate like mixing with the cold surrounding seawater, that's why you get a lower temperature there. And we basically now continue our pumping from the subsea floor, hope that water is getting into the bag, which I'm not so sure of at this moment. But we will stop this in 5 minutes, and then we will start trying to crack the rocks again and see what's underneath here.
Excellent. And I missed this morning what was happening on the dive, but was there still that sort of snowstorm of bacteria when you guys opened the box up?
Yes, it was still there, a little bit less than during the first recovery, but also expected because the temperature is lower here at this place. But there was still a lot of white, flocculent material coming out.
Gotcha, cool. So we are keeping an eye on this bag with the one camera available to us. We can get that angle. And once that's filled up satisfactorily, I think we'll move on to everyone's favorite rock breaking section. So that was a dramatic part of this first experiment recovery a couple days ago. We'll see how that goes today.
They were terrible.
Occasionally we have snacks up here, and I mistimed my entry back into the multimedia seat. There are no more snacks for me. No thank you, Alex, but I appreciate the offer. And in the front row here, a little bit less of a crowd while we wait for this bag to continue filling. Dr. Spina Gallner and the scientist Mike Chill is doing a fantastic job piloting at this very second.
How still the ROV is.
Stuff is very stable. Alex also contributing as co-pilot. Those manipulators are also incredibly stable.
Only for 2 more minutes.
Yeah, this is Alex's strong suit. Standby mode.
Can you do a white balance real quick?
And this is Tyler, one of the Marine techs on this expedition. Previously and in the future, an RV pilot on the other mic. Filling in for our man, Alex Havens, who is getting a well-deserved break in the middle of the day because he is here throughout the duration of the dive.
Ready? Oh, you're I see. Yeah. I think
Yeah,
it
it
is
is,
strong
yeah.
something, but I think it might
I
be a
think
slow
slow,
flow
yeah.
for some reason.
Yeah. We can stop the pump.
We're getting ready to stop the pump here. Some things will happen, and just a quick shot of the weather we got out here today. We've had some gorgeous weather through most of this expedition, but a little overcast today. For anyone keeping tabs on the weather here.
Best you can see, right? I think so. We're done yet.
So,
For sure,
yeah.
we're done.
Yeah.
The sideway crab is going to be easier.
Yeah, like from the
That's
outside.
not necessary. It's up to you.
Which way would you grab it from? Like, from the front?
Yeah, so if you were able to reach around it and come back a little bit, it would be the easiest to get it back in the tube. But not necessarily the easiest to grab.
Ja, die Berggefühl ist das, weiß ich nicht. Das ist irgendwie langsamer, glaube ich. Müssen wir schauen.
Das ist noch gut.
Das ist gut, ja.
Die Temperatur ist aber relativ
As
hoch.
we
Die ist 24 die ganze Zeit, bin total stabil.
mentioned a few times previously on these dives, where the pilots are gripping tools is integral to the success of maneuvering those tools on deep sea. Because you do have a reasonably full porch here, so getting sensors back in their holsters or back in their spots on the porch can be a bit of a finer, require some finer movements than at other times. a top-down view here.
Ja, jetzt ist entspannt. So ratschelt
And,
Schauen wir, wie es geht.
holster they're fitting the
Ja.
high temp probe into was made here on Falcor 2, so the ROV team will often
Genau, richtig.
design and create their own
Wieder mal Abbruch.
implements, brackets, and other things for the ROV. Always trying to make it easier and more efficient and quicker. So the less time we spend trying to get tools in the right place, that means the more time we have for science.
Do you want to get first also the large chisel? Probably?
The large chisel?
I don't know, like yesterday. To have it ready if it's needed.
Sure.
Some on the left side here, I think.
Let's go explore.
Although it's next to the hole, yes, that we left yesterday.
So we're going to retrieve the big chisel. So we brought down 2 chisels. There's a smaller one that's in the port, in the nip currently. And the larger one, which you see on screen right now.
Just grab it and with that arm we got, just to get it over there and then just grab it.
And that is what we're looking at now.
You need to hold it.
The site of our very successful recovery of Experiment 1 a couple days ago that revealed 2 worms growing on the underside of the rock that was covering up that hole that's on the bottom left corner of your screen. And that was the evidence that scientists were looking for, that tube worms are traveling through the hydrothermal vents. So it was a novel idea they had, and it took a few years to get this put together, and success the last time we recovered an experiment.
Yep.
Box. So we bounce around a little bit.
No.
Give you the sit-cam view here, while Chill sets the sub down on the seafloor.
So basically, we're going that whole Schmidt left and see if we can right up.
Yeah, so when we were in there eating, I was watching him put the chisel in that crack and prying towards the left, and I think this right section was loose. I think I have moved, so maybe it'll.
No, I think that was my perspective too.
But yeah, just go wiggle around in there and this guy.
Oh, with the small chisel.
Yeah, that's not. I would just set that aside. See what's inside. I'm not very stable.
I was thinking this was
Sitting on the suction tube, I think.
So you may have heard Chill there mention that he was watching while we were on our lunch break. And so there are screens set up in the mess on our research vessel Falcor 2. So scientists and crew members can keep up with what's happening on the live stream. Got screens all over the vessel, in fact, in the labs, in the hangar. And so the marine techs and multimedia tech can put up different things on those screens for whatever we need, or just to share what's happening on these dives.
Where's the outline of the original box?
You can see the red corner right there.
Too low. Oh, okay. Right. So we're in the right. So we kind of need the left side of that to break off, right?
Yeah, this would be good, but yeah, I think there's no way to predict it, whether they will break off. So
So we got. Plus, it may end up like the last time.
Yeah.
We get
The
the piece
piece.
out.
Pop
and
up
then
the
better piece
red silver
Yeah.
here for a second. So that appears to be the corner of where
move it like
this box was.
that. Probably, but first probably see how
A
how the
nice
plates move,
crisp
basically.
outline right there. So the pilots are working to pry up some rocks from within that experiment site. And again, if you're new to this stream in particular, so that crack in the center of the screen that the Alex has worked the pry bar into,
You should never
the shimmer coming out of that is
using commas.
hydrothermal vent fluid.
Try to split the values in commas.
So whereas
Split this commas and
a lot of times hydrothermal vents will feature chimney-like structures
next.
and thick black plumes or flumes,
Underscores.
this venting is coming from cracks on the seafloor.
You can convert it.
That's pretty
Sorry?
You can always let it go if you want. Just kind of like push it out. I don't know if that's better or not.
The problem is you need to convert the values in commas.
I'll try to find
Freeze, like, a lot of that. Sometimes I do it a couple times and then we relieve all that stress.
not that way, but sorry. Actually, rotate it. Should we want actual grab on it?
That's actually one good thing Zach was doing, is he was just like twisting it, loosening it.
Like with the wrist.
Yeah. Instead of a bunch of pride. Just kind of taking it slow. Just loosen it.
And there is no exact process for getting these rocks up, so a lot of it's trial and error, attacking it from different angles, but the pilots are using what they learned the last time we pried up a rock and earlier this morning. Try to come up with the best method for peeling up some of that seafloor. And so if this seafloor is similar to what we dug up the other day, it'll be about 3 or 4 inches thick, and it's a bit weighty.
Same method you're using to push the RV back.
Yeah.
Is giving you a good angle to get under that rock. If you continue doing that, you're doing, yeah.
Put it a little smaller plate here.
Underscored. Yeah. Or maybe I should be
Okay. It's
I put myself in this spot now, but I can't push that straight.
So occasionally you'll see some move around a bit when we're working that pry bar in there. That's because Sebastian is slightly buoyant. Even though it's a heavy vehicle, it's not going to sink to the seafloor. So when we set down, the pilots are actively thrusting down, but Sebastian wants to rise up. Getting the right balance and the right leverage. Pry a rock like this is no easy task.
You're a little low. It's a little bit up. I'll zoom in over there. It's moving. Just keep working.
Do you think that probably the other side would break more easy? Like this here probably it could
We can
be
try
great.
again, but
Yeah.
we did try that side and nothing moved.
Okay.
It was super hard,
Yeah.
but we can try again.
Grab the rebel.
Thinking about it.
You can see the starboard manipulator sneak into view on the sit cam that's in our picture-in-picture. So right now each pilot has control over one of the manipulators.
Slide back a little unless you push me back.
See the whole thing?
Yeah.
I think that we did a good purchase with that red one. It might be
Yeah, they're more interested in that rock to the left, so I don't know if I can get in there with the big bar.
yeah, try it.
The right is also fine. It just looks that the plate is very large on the right side.
Yeah.
I'd try that. Maybe one side.
Yeah.
I wish I had a deeper grab on this bar. But
We can hand it off. I can set this down.
might be able to just jam it in there and get a deeper grab. I'm not sure.
Mhm.
Bad idea.
No.
Yeah, I gotta deeper it out. Also kind of need to be up higher so I have more leverage.
Chill's gonna use some basic physics here. Reach up higher on that pry bar, get some more leverage.
It's not moving, yeah. Yeah.
We had this view, we tried this bar, go in the same direction you were doing with the other one, and I will reposition it in the meantime. There you go. Jeez.
Very good. Ooh, yeah.
Yeah, you're getting somewhere. You could almost open your jaw. That way it has room to move and not bind
That's
in there.
good.
Just pry it down. Jeez, there you go. Yeah.
Ah, that's good.
Hold on, let's reposition before you do that because it's going to be very difficult for you to get this flipped. And so what I did when I did that one the other day is I grabbed the bar real close to the rock and I just kind of leaned it over. There comes all the bacteria out of the hole. But yeah. And I need to turn you almost 90 degrees.
Oh, yeah, don't stir the sink, yeah. And then hit it that way. Put it that way. Too little.
See a lot of that
I'm almost wondering if
flocculent
it'd be better to go
bacteria
in just the jaws
flowing out
open
of
that, or
the vent.
lift it that way.
Yeah, you can try that.
Because I feel like you'd have a bit more control. If you can see through that. Well, yeah, I think you could totally reach under there. You might even be able to get with one finger. So we're trying to flip it over.
I think so. I mean, I don't know. I guess if we could just grab it and pull it out, it'd be fine.
Let's do it. So I'm just going to hold the wizard staff and start with them. Something else. I don't want to just put this down.
Yeah, I don't think we need that anymore.
I'm just going to measure with the jaws for now. So I have an idea of how big it is. And if it works very bad, I'll think it's not.
Zijn kleine gedieren, je zegt van zo loog.
Ja.
So Alex is going to use
Zal
the
ik met die eindvan
Ja.
jaws to
One
kind of
moment.
gauge how wide the slab of rock is.
If this hole is really large enough to get in with the suction sampler, we would like to get a suction sample out of this.
So now that the pilots have created a reasonably sized gap there, scientists are asking if we can
Number 3.
get the suction sampler in there and get some suction samples before prying the lid off, so to speak.
It's fine.
Because every time we
No, fine. The old
make a
ones we've
change
already
to this experiment site, it's going to, of course, change
used. The others we've already used.
what's happening.
So 118.
So they're looking to get samples as quickly as possible, as soon as they can fit the sampling device in there.
Yeah, that's fine. I'm just bending it.
Just gonna set it down.
Well, yeah, I was just waiting to see. I was
Yeah.
just doing it around.
No, you're good. I was just trying to let off some of that. I had a bunch for us Brian.
Yeah.
I don't need it that way.
That's probably close enough.
Alex is setting down the red pry bore, or as he's termed it, the wizard's staff, so we can grab
Grab it all.
the suction sampler nozzle with his starboard manip.
Also, once it's stable.
You can get there, because by 4 hour.
Yeah. Make it more determined.
So in order to get a little bit more reach on the suction sampler, the pilots are porching out. You can see our suction sampler hose is bungeed to Sebastian. Keep it contained to the front of the sub there, and so it doesn't flop around too much.
If you yaw right, oh, you got it, that'll work.
If we can try to get it in as steep as possible, I would say.
Still is on there. Creep. Yeah, okay, coming forward.
And you can see with this view on our sit cam, the arm was out pretty far. So Chill is going to ease the sub on forward. Make this a more manageable reach for the suction sampler.
You can highlight fingers in it.
Should stay close here.
Have it.
Nope, you're on the box. Stop. Let me porch in. We're just gonna have to pull on that one. What it is. And now we gotta worry about that probe, but
Unless you wanted to spin the heading a little bit.
to the left.
They say football is a game of inches, and so is deep sea science. So Pout's porched out to get a little more reach on the suction sampler. That also brings that blue cooler we've been using out a little bit. So they don't want to bump that too hard with the arm. So they have to reassess, come at it from a little bit different angle.
Start that way, present some challenges.
Very good.
Ready for there?
Mhm.
Section's on.
I mean, that's grand bread, I guess, it's not those.
And with the suction sampler jammed in that crevice, I'll also turn the suction on, the pump on. So we got a little view of jar number 3. See some stuff starting to spin around inside that sample jar. a little bit of a different view here from the, oh, it's our HD1 camera. You can see the science cam in that view. The cam does have the rail system, it can come in and out, pivot up and down, pan left and right. That's what sent us our 4K stream. Also in this shot we've got the starboard manip, one of the upended experimental boxes, and then right in the middle of the screen is experiment number 3, the final of this series of 3 experiments that we'll return to, I believe, in a couple days. Go through the same process.
Like 5 minutes or 10 minutes, what do you think is good? Yeah, I have no idea. Yeah, you see some parts going in, but of course you have no idea what it is. So, okay, so probably 10 minutes total, just to let it wash. Yeah? Wash. Would be my guess. Yeah. It's a very good position. Yeah, it's perfect. You have a good picture, Dennis? Looks good. We should equip all the suction samples jar with the ultrafine mesh, I think, for the next times.
Got Dr. Monica Bright, principal investigator of this expedition, in the room conferring with Dr. Sabina Gallner. Just saying the position of the suction sampler looks excellent. Just gonna let it run here and see what they can get. That object drifting into the left side of the screen is not a new gelatinous deep sea creature. It's a leftover silicone that was sealing that dye box down to the seafloor. So it just peeled up when they pulled the box up.
Okay.
Wie jetzt das fein, was auch passt.
Wenn du hast 1, 2, 3, 4, 5, 6, also wir haben nicht 1, 2, 3, 1, 2, 3 ist praktisch fein, 4, 5, dann tun wir das 6 und dann praktisch 1, 2, 3 fein, 4, 5, 6 ultrafein und das 7 grobes.
Ja.
Den nächsten auch kommen besser, weil das ist der gleiche wie der, aber da schaut jetzt genau das, was wir heute gemacht haben.
Ja.
Und dann so wieder die Sponge.
Den nächsten für morgen. Sehr gut.
Wieder von der Underworld machen. Und die Sponge ist so, die wegkommt. So.
Ja.
Ich schreibe das.
Sehr gut.
Switch up the view here a little bit while we let the suction sampler do its job. So if you're brand new to this expedition, this is coming from our sit cam, so that's the top-down view the pilots use. And those white objects are Riftia tube worms. And they have the red plumes. And so that's one of the organisms the scientists are particularly interested in. And so the idea they've been working with is that these tube worms can actually travel through the hydrothermal vents. So rather than moving through the water column to repopulate, recolonize an area, they go underneath the seafloor. A bit of a seafloor subway through the vent fluid. So they've been doing a number of experiments to test that hypothesis. Tons of sampling, seawater, geology, biology, looking at different sites. But there was a breakthrough a couple days ago when they, in a day like today when we're clearing out an experiment site, cracked the seafloor, flipped it over, and found evidence of tube worms living underneath, on the underside of the rock they flipped up. that was in the hydrothermal vent, and the only way those tube worms could get there would be by going through the hydrothermal vents. So they've reproduced that experiment 3 times. This is the second one. So continuing to collect data and hoping to flip another rock over if possible. But for now, we're gonna let the suction sampler suck. So Sabina, what kind of things are you hoping to get from this sampling?
We want to know if there are any species that can live also in the underworld of hydrothermal vents. Want to find out if it's basically the same species as those that we find on the surface, or if it's an additional species. So yes, 2 days before yesterday, we observed that the tube worms can live there, and now we want to also get to know if also other species can do this. That's why we're now taking this suction sample. And also before, where we took the small water bag.
Gotcha.
And we can stop now the suction.
Okay.
Gonna stop suction sampling. And that's also why it's important to try to get the suction sample in there before you pry the rock
correct,
up.
because
right?
when we break it up, then of course you get a mix again of the different environments. That's why I wanted to have now the sample here. It's just a perfect opening. Fit.
Excellent. Yes, that's the pilot's pried up just the right amount of rock to get the suction sample in there. So the scientists want to keep that environment as undisturbed as possible while they pull these samples, because they want to see if there's anything that's not on the surface of the seafloor that's down there. And once you pry that rock up, there will be mixing of the seawater and the vents pretty quickly. So it's a great opportunity to get the larger suction sampler in there and see what they can get.
Stuck. Reach around.
Yeah, I will, if you want me to. If you're comfortable doing it, go for it now.
But I think we don't need any suction sample anymore, just it's important it's closing.
It's true, but
Yeah.
if we leave it in dirty,
Mhm.
your sample
And
you
it's
just
like-
took will dissipate
yeah,
through there. I
yeah.
have to move it
Yes.
off.
Yeah.
Let's see.
So when the pilots finish a suction sample, they will spin the jar, because right now it's open to the tube, but once they spin it, it'll be sealed against the top of that jar arrangement. So after you get a sample, you spin, put it on a new jar so that what you've sampled does not flow out through the tube. But on occasion that mechanism gets a little sticky, so it needs a little bit of manual help.
Honey? Oh, you're okay. So we just bumped the bungee that's holding the valve for this.
Yeah, push to the back side.
Yeah, it just came. It may have came off. I'm not positive. Or
We'll go take a look.
that's important. So let's just.
Oh gosh, I'm waiting.
I think it actually fell off.
Mm, yep.
Yeah, it did.
You can rack out and see the line moved. Or let's just stay still.
suggest that we first put the spongy on, the rope on, sorry.
We can't do anything in the section sampler.
Yeah.
Just curious.
Because we first recover the suction sample, like the hose, and then try to get the rope on there, and then try to move this. Or what is, I don't know, what do you think is better?
Are we between samples right now, or is it still a sample?
It's between.
Since your samples say.
I don't know, but I would rather be
Sure.
positive. Yeah, so she wants to pull the suction sample tube first, and we're going to put the plunger back, and then we're going to try with this, but we may end up pumping that again.
But we don't need the suction sample anymore. The sample is finished.
Yes, I understand,
Uh-huh.
but if it's not off of your sample could float back through the tube.
Ah, okay, I got it.
We
Okay.
have to move it off
Okay.
of 3.
Okay, yeah, got it. So you would rather do this first?
I really don't care what we
Yeah.
do first, but I just know that we need to move it.
Yeah, okay.
There we go, flat.
So you got the team up here in the front row working through the order of operations. Got a few things they're going to work on here. Removing the suction sampler and installing it as best they can. Trying to re-engage the jar mechanism to get switched over to another jar so they don't lose that sample if it flows out backwards through the tube. And then there's a bungee that got loose.
It's not going to go there anyways, the thing's bent again.
Yeah, just wouldn't make sure it's below the curve. Just 'cause I don't know.
Let's get the bungee back. Right now, so you see the tip. There you go. I think the bungee has loosened somehow. It's not here again.
Sorry. I was watching it, that's what I was watching.
Okay, so before you loop it this time, what if we,
Kind of some twists or something.
yeah, that's what I was thinking, twist it, so it'll be tighter. Before we, but I don't know how that's gonna work on the side here. Yeah, there we go.
what the pilots are working on right now is there's a large bag sampler on board Sebastian, and it's operated by a pump, and the controls are on the left side of the screen here.
It does not seem like it's tied in.
And those handles turn the pump on and off and change the direction of flow. There have been a couple issues with
Oh, it's fine. Okay. We might have
that pump, so science team devised a strategy to try to bungee that handle in the off position to safeguard the 55 liters of sampled seawater so it doesn't flow back out.
all we can do is give that valve a tap to the off and just make sure it's all the way. We'll have to read about the bungee when we get it.
Yeah, that looks good. Okay.
Okay. All we can do.
Yep. Good.
So now back to this guy. Sure you saw everybody's things around.
No use. What is this? That's no use.
Got that now.
So jammed up. That's what fires way high.
Yeah.
Well, I was on the suction side. That's fair. Doesn't matter which way.
So
I'm
number
trying to go to
6
two.
is.
So if you
Push on
did,
6 away from us.
yes.
Sure that. Or we push harder.
I'm trying.
Probably work.
It's not going.
Now we'll throw for one after the same goal.
Still in the same spot.
I'm pushing the jar on the frame right there.
You can try to go the other way, and if I can get it back to 3 and back on track, maybe I can get it to
I just took a free to push on 5 because that stuff in it, but I think I should.
I don't know if you have a choice.
But, well, try that. Other one?
Go on, nice and easy.
Can you check it the first time?
Mind if we give it a try?
Yeah, of course.
There's the old one.
You're just tuning in. This is live footage from ROV Sebastian, and you are watching our pilot's troubleshoot a finicky suction sampler system 2.5 kilometers below the surface of the Pacific Ocean.
Which ones do you want to select the basalt?
Box 6 and box 7. This is our two firms. I want to just write I want to picture. You can give me, if you find it, the picture where everything is on, then
So they're trying to give the jar a little nudge so they can engage the motor. And again, the reason why they want to move off of the jar they just sampled into is because once the jar leaves the sampling position, it's effectively sealed. But in the sampling position, there's a chance that the samples in the water in there could flow out through the hose.
Just one. Yes, so these are safe? Yes? Good, very good.
And we'll give you
Good.
just a quick recap here
Thanks a lot.
while we get set up. This is the Underworld of Hydrothermal Vents expedition. These are live images. 4K video coming into the control room from ROV Sebastian. Control room is on research vessel Falcor 2. Both are operated by the Schmidt Ocean Institute.
Good, so now we want to flip the rock over with the mega
Got
chisel.
the exciting part coming up.
Yeah, we can flip it. It might be, we'll see.
Flipping of the rock.
Maybe not need the chisel for it.
And I will leave you in the capable hands and with the soothing voice of Alex Havens, our multimedia technician.
I have to leave the chisel anyways.
He missed the excitement first time we flipped the rock over, so hopefully he gets something good to watch here. Right now the pilots are going over their process, and I'll leave you and Alex to witness what's going to happen next.
The picture
I'm just gonna grab
the
that.
snapshot
For the original firm, I'm just slide the red bar.
and setting for observe.
Yeah, but we have to find where they are free and we have a free space just to run
I have this picture is observed. You want a picture like this and the snapshot of
Wait a moment.
Die sind nur 3 von den Dingen, ne? Mit den Sponges.
4.
Ja, schon, aber 4 auseinander. Und das ist ein Paket.
Genau.
Wir haben 3 von 3
Mhm.
Also we need to find a picture all three of them.
But they're very close together. They're next to each other. They're next to each other. Mhm.
Cool thing is this big building institute. Only if you play, but if you flip it underneath the rock.
In those cases, you want these snapshots with the
This frame also.
long lab.
Yeah, just give this also.
Did the artwork from yesterday come up alright?
Sorry?
The artwork from yesterday come up alright?
What can you say?
Did you land the artwork you brought up?
Yeah,
Did it
yeah.
come up?
It was wedged. Good job. Okay, yeah. I slid it in and then rusted it up and put it into.
All right, folks, for anyone just joining us, we're in the middle of working with the rock here at experiment site number 2,
What was kind of tricky, was kind of
down 2.5 kilometers on the East Pacific Rise.
It's kind of measure sizing it up with the jaws, just to kind of see how big it was, because if it could have, a chance of being controlled. Otherwise, you're just going to run samples with the jaws. Yeah, because that way.
We have ROV pilots Chris and Alex working to approach how to pry up some of the rock here.
We have to use a bar rescue for it, so it's easier. At least I have. Or gift or something. Oh no, because we were way earlier. Yeah. Like, really light. Maybe someone up to. A little closer. Yeah. There. Hopefully that'll give us a good speed with that.
So just repositioning here. So we've got about a little over 2 hours planned time on the bottom remaining, although that can change depending on where we are with our objectives. Looks like the internet's holding pretty well today. I know we've been keeping an eye on the weather.
Yeah, it's big. So just go on inspection, I guess, give it over 100 and try to just do it. So.
Oh, that's cool, you can see. Very good.
Yeah, that's what I meant to do. Perfect.
All right, so we'll just let
Let's leave
that
it that we see a bit
sit
what's going
there.
on.
So what would your workmates say if they saw you using such functions like that? Oh, yeah, basically, we know what they look like in the back of our day. Like, oh, that's how that happens.
Okay, very good. So, can I use the camera? Can you leave the rock like it is?
Oh, yeah.
Yep.
So, park here, so you're not even nervous. Nothing's missing. What's going on there? Try to get you as clear a shot.
Haha, Monika, schau mal. Look at that.
Yeah, more life under the rock.
Where is she? She's again gone.
Not even in here. No, I'm sure she's watching on the screen, but wow, this flow though. But there's definitely some life there.
That's like yeah. It's like life, like it's not only tubes, but the
Right, because last time we found like the tubes.
Yes,
It's like
but
there
this
was
time
something
we have
here.
yes, it's
Yeah.
alive.
Yeah, yeah.
Oh, that's so wonderful.
Can you stop the shimmering?
Monica, cue fast.
We found the live one.
The live one.
She's not so excited.
On the other side?
Yeah.
Yes. Then we're lucky. So.
Und fährt oder wie?
Nein, das ist, also, das ist, schau, das ist der Sturm.
Ah, der ist aber nicht, ist der genauso groß wie der andere? Oder?
Weiß ich nicht, aber das ist da und da, das ist Leben.
Den nehmen wir mit.
Ja, und da, ja, da sieht man steht den Rand, aber wir sehen, man sieht jetzt nichts wegen dem Flow. Okay, Salva. We make like this. We make first the highlight.
Aber der ist unten. Nicht.
Und da ist auch eins. Schau, da,
Ja,
1, 2, 3, 4.
Der ist unten nicht so weiß gewesen wie der andere, aber wir haben es ausgesucht, warte mal. Wissen wir nicht.
Genau, ja.
Okay. Den können wir ja nehmen.
Ja.
Ist das big or is this not big?
It's big.
Okay.
It's so the last one, thickness wise, fit just inside the jaws.
Yeah.
This one's a little bit bigger than that.
It's getting better and better, you know.
It gets better and better. You know what? But
So the
cannot, if you
previous rock slab was something like 30 kilo, maybe 40 kilo. We're thinking it was quite heavy. This slab is thicker than last slab.
Oh, now it's floating away. Okay, this
The
is
area of it's a little smaller, so.
It's not floating away, so you can write down in the notes. There is, he was sitting there, and there's another one.
No, yeah, it's
Yeah.
away.
So it's.
Can you suck it up?
Can you suck it up, these two? No, but
Well, why not?
yeah, why not? Yes.
Maybe
In
we
char number.
keep it. Okay,
Okay.
that guy really swims away. Where is it?
Here, there. This one goes away, but the other one is still
That,
there. Here, this one. Can you see it?
Yeah.
Are you happy with the being an A, or are you gonna move it?
Okay, one is still there.
Here, it is there. I will follow it. You have to be really quick with
Yeah,
the
but
suction
it's-
sample.
Okay,
Okay, we have it on video, and it is nearly
there we go.
two of them. Size about probably 4 centimeters, 5 centimeters.
All right, so they're working to try and get the suction sampler.
No,
No.
they're red anyway. But here there's.
Now you don't have to. You can put it away.
there's another one.
Add another one.
There's one right here too.
Try
Which jar should we take? One moment.
But when to the left, fine, we have.
Nah, we have no fine left, so we need to. Let's do it. Add it to number 3, which is the fine one, and it's also from the Underworld.
But I see, two worms. But I cannot see this. We need to
That's
put
3.
to push it out. Also.
That's number 3. Yes. So if you can try to get this animal in
Which one do you want?
Yeah.
this one.
So do you think these were alive or dead?
They were alive. They were crawling and swimming.
So they were like down there? or
Yes,
sitting?
they were down there. Like I don't know if all the time, but they were living there.
Cool.
Very cool. Super. So not only.
As far as like clarity now, it's like,
This
but they are
doesn't
big enough that they can fall down or float away.
Huh?
Suction's on the way.
Yeah, such as that for now.
But we don't want to mix the sample with the other stuff. Stop it. Sorry.
Alright, suction's off.
Yeah, but this is not. This is not the same. This is
But-
Par Vanilla.
But wait a moment.
Yeah, okay, but this is
Stop.
Par Vanilla.
This is sitting right there. This will not fly away, swim away, probably. This is par alvenella, and
Look
this
at
one
this
also.
And this
And
below,
this one,
is a,
But wait, I think we still need to take another jar because we do not want to mix the jar
Yeah.
number 3 with the other
don't
one.
mix it.
So we take jar number 6, and it should be large enough to get
Can you take a
also.
picture, Sarah?
Sorry for that.
Okay, there are several on it. It's not
All right, working to get one of the collection jars ready for this. Obviously, some of these worms are more mobile varieties, so they're just trying to get a couple. Despite the shimmer,
Get the suction on and just. change the angle of the,
Yeah, this fence.
yeah.
Yeah.
Doesn't matter what I do, just I'm not gonna get the angle. Just,
This one's up off the rock a
yeah, but I
bit.
can't.
Oh, right, yeah.
It is.
Yeah, I'm not so sure. No, this is not necessarily in a release. It would be good to find what was this Galapagomystides.
No, it's not Galapagomystides. No,
Huh?
it's not Galapagomystides.
See if I can,
It looks very much like this for me. But if you collect it, we can see.
Mm-hmm.
Maybe grab the hose just below it so you can get it.
Okay, this is
yeah, I can do that.
not red.
I don't want to cut it with a cut.
That's fair.
Just zoom in.
Met als een nanotubes drauf. Dat zijn tubes. Zo.
Als je schoen los kan voorhouden, ik zei het ook fotograferen. Zo opstaan. Dan kan ik er ook niks afvallen. Dan kan ik er ook niks afvallen.
Met was het niet.
This and give you the angle.
Kind is niet samen. Ja.
Dan hebben we het een stuk op de zijde.
Mm. Want das können wir noch mitnehmen, das ist ein kleiner Schal. Das nehmen wir noch mit.
Mit Steen, was kalt ist, dann kannst du schöne
Yeah.
Fotos machen.
Okay, we try something else. Is it possible to flip those outside? Then we can get a better view on it without the shimmering, and then we can make pictures.
What, you flip the whole rock out?
Yes. And probably first, before we do this, we want to collect this piece here into the blue, into the cooler.
Alright, so
Daar heb ik me eerst dan eens voor
that piece right there.
This one, this
Yeah.
should be.
Met deze.
Alright, so open it and then
Dat is
pour
al
it on
cracked.
the
Mhm.
break that
Ja.
off.
Dat is
Yeah,
wel zo
alright.
klein over.
Ja, aber da ist kein Dings hinten, gell?
Was?
Da ist kein Flow. Wenn du das abbrichst, dann.
That's usual. Probably not.
Oder? Ja.
So
Jetzt keine Ahnung mehr, wo es anfängt und aushört.
Da ist der Riss gewesen.
I don't even know if it's gonna be going out.
Oder? Nein, da hinten. Ja.
Das ist auch nicht das Ganze, aber der Crack durch,
Genau.
das gehört noch uns und
Genau.
das gehört auf jeden Fall uns, das gehört
genau.
nicht uns, das
Ja.
da und das da.
Genau.
Fine out.
Rein theoretisch zumindest.
Mhm. Ja. Da hängt nur der Dings.
Also,
Unfortunately, as much as I can.
Ja, ist auch nicht.
Nein,
Which isn't not gonna be enough.
okay. Der ist dicker.
Yeah, alright, I'll back up.
Is that assembly found?
No,
No.
but it was on, no? Or was it on?
Very short time,
Very
yeah, but
short,
it was
only
not.
like little bit. Yeah.
It's super heavy. Alright, we'll just do this real fast and I'll fly back up there, get as close as I can.
Right.
Which out, this would Alright.
You're putting the rock through it quickly?
Mhm. Hm? Bitte? Mhm.
Die erste Info fotografiert habe, sind gelb-weiß, also sind nicht rot und der rote ist ein anderer.
Okay.
Right,
Das
so
sind schon Tubums auch.
Ja, ja, genau. Mhm.
I can't do that anymore, so we're gonna do all with the sit.
So we're positioning ourselves to collect some of this rock.
So break the rock, then I'll forge out, then we'll open it up, then we'll put it in.
But the small rock should be already loose. The one was
Yeah,
in
we
the
can't see
corner.
it.
Yeah.
Yeah, it's just,
We're roughly
it's right below you. It's, yeah,
I wouldn't see that.
yeah, it's right there.
Okay, that's it.
Give
So,
me,
yeah.
the one just in front of it.
Okay.
No, upward up.
Sabrina, will you sample number?
This would go to the blue, to the cooler, so this sample we already have.
Yeah, like just, what's the,
Sorry.
right there.
Oh, that one.
Yeah.
1919.
No.
No. One moment, Salva. Just give me one moment. This belongs to sample number 115.
115.
Mm-hmm.
There you go. No.
115 are the dead tube bombs and alive mussels. And we said we want to collect the rock also in
Yeah.
there. If not, then we have to
Yeah,
use
okay.
another firebox.
Yeah, this is okay.
Yeah.
But the
Yeah.
number of the sampling is not 150, you make a new sample.
Ah, okay, yes, the new sample number is 100.
You put it in the same box.
So we go new sample number 120.
120 and 119 is kind of not.
Yeah, so just close that. I'll forge it and then we'll remember. It's the only way we do it.
So it's not.
We have no good options. Alright, portion it.
Now, notation.
Now we have 120 for the rock.
This.
Okay.
So we can
Let's
take a
do
film.
that one right there, yeah. Pretty good. You gonna sit. Yeah, and that's definitely good for you. Nate, the best use you have in the sit.
That's not me, man. I can't see that.
I can scoot up and then scoot back.
Yeah, that's fine. Hold the light, can you give me extra light?
Sure.
With all the time, you can take it slow. So I'm gonna take a highlight phone grab and make a note from the camera.
Javi. Javi.
Can you print?
You want to print this? Let me have it to Javi.
Hola, buenas tardes a todos. Buenos días también, dependiendo de dónde sea que nos acompañen. Acá están conectados a el live stream de la expedición a bordo del Falcor 2 del Schmidt Ocean Institute. En este momento están viendo imágenes en vivo gracias a el ROV Sebastian. Les habla Iván Rodríguez Ramírez de la Universidad de Costa Rica y los voy a estar acompañando por la siguiente hora en la sección en español de este live. En este momento las imágenes que estamos viendo es de colectas de rocas del sitio donde previamente estaba instalado uno de los experimentos importantes para esta expedición.
Ah, okay. Okay.
That way, at least
Yeah.
if
All
it
good.
falls, I can pick it up off the box.
Okay, very good.
Coming, come on. That'll be very good.
El día de hoy en la mañana, si no pudieron ver el live desde el principio, se realizó el recogimiento del segundo experimento que se instaló en esta zona. Hace ya 3 días recogimos el primero, hoy el segundo. En la mañana lo que se hizo fue levantar la caja de malla de 32 micras que estaba sobre una de las grietas acá en la zona. Se absorbió el agua que estaba en la parte de adentro, se tomó estas muestras y se guardó la caja. Bueno, la caja la podemos ver ahí en pantalla en la esquina superior izquierda, pero luego esa caja se va a guardar acá en el ROV para llevárnosla de nuevo a superficie. Y en este momento lo que estamos haciendo es colectando rocas de la zona debajo de donde estaba esa caja. En el primer experimento ya habíamos tomado una colecta bastante importante de un trozo de roca bastante grande para poder ver la parte de abajo de estas rocas, a ver si habían organismos pegados a ellas. Y en efecto, si ven el video van a ver que hay algunos tubos de gusanos adheridos a esta parte inferior de las rocas. Entonces acá en la mañana se intentó romper de nuevo los basaltos para poder agarrar una muestra similar. Podemos ver acá en la parte inferior, atrás de donde está en este momento el brazo del ROV, hay una sección de los basaltos ya rotos. Así que lo que queda es recoger parte de esta roca para analizarlo acá a bordo del Falcor 2.
Die großen Steine kriegt man so nicht.
Ja.
Das können wir mal fragen, das sind vielleicht weiter aber die anderen.
Aber Foto möchte ich noch machen von denen.
Die auf den ganzen Box, oder was?
Ja, das kann man immer machen.
Magst du mehr Steine?
Ja, ich hätte jetzt offen lassen, aber man er soll vielleicht auf die andere Seite mit dem Abbrechen.
durchbrochen, das ist da so geblieben. But this one is very solid. This is the first thing that they tried, and this they could not lift. That's why I went into the other direction. So you cannot break off here, please. That's not possible because it was not move. It didn't move like a single millimeter with the chisel. Okay.
Das andere was wir machen, wie probiert das dann mit den anderen Papieren?
Bitte?
Den Stein kann man gar nicht vor irgendwie. Ich weiß nicht, ob
Jetzt machen wir mal die Box zu, oder?
Dann machen wir die Box zu, sonst
We
können
can
wir
close the cooler. Und dann think müssen wir dann Fotos machen, dass die Viecher draußen sind.
En este momento las investigadoras principales están discutiendo la mejor manera de tomar las colectas. El día de hoy la mayoría de la inmersión está dedicada justamente a solo recoger el experimento y las colectas de muestras relacionadas a él mismo, pero también se intenta aprovechar un poco el tiempo para tomar muestras de gusanos riftia que se necesitan para experimentos que se están haciendo a bordo del Falcor 2 y también muestras de rocas de otras secciones y también para experimentos a bordo. Entonces se tiene que trabajar de una manera bastante eficiente para poder aprovechar el tiempo al máximo y lograr todos los objetivos del buceo del día de hoy.
Well, no, I appreciate it. I think the bushing may be worn out, you know?
I blame Ben. Pitching it.
Okay, and we want to get a good look at this rock now.
Alright.
So we can make pictures of it. Probably have to move it a bit out of the shimmer, but you will see what we will get from this angle.
En este momento nos vamos a acercar más a estos pedazos, secciones de roca que se rompieron para poder tomar videos de cerca de los mismos. Esos videos se guardan más allá del live en YouTube, se guardan en la memoria que tiene el barco. Y los científicos a bordo tienen acceso a los videos y a las fotos que se toman durante toda la inmersión. La ROV Sebastian toma fotos, de hecho, cada minuto de todas las cámaras que tiene alrededor de su estructura, y así los científicos pueden analizar de nuevo todo lo que se vivió en la inmersión.
So, if I can push it over.
Ahora se está discutiendo de que lo mejor sería mover la roca de donde está en este momento, ya que, como podemos notar en la imagen, está justo en el centro del flujo de agua caliente de esta ventila de flujo difuso. Eso dificulta un poco poder ver de manera nítida la roca, así que se está intentando planear la logística para poder moverla a un sitio con menos flujo y poder ver de manera clara todo lo que está debajo de este basalto que se acaba de romper.
They lift it. Let's try. Let's see how it
Well,
goes.
is there any chance I can move the other one out of the road first? Because it's pinning it down, right? If I can move that other one like away, because it's pinning it this one against it. Yeah. If I can move this one out of the road, like that way, there'll be less resistance on here. It's just sitting on
Yeah.
top. I'll give it a go.
couldn't get it over earlier. It might have just been the angle.
Jam it in there. There's not left in the
Parece que este trozo de roca es muy pesado. Acá los pilotos están haciendo lo posible para poder moverlo.
I don't know if you have juice to do that. That's a big chunk. Just give it a second. Give it a shot. You want?
Alright, we'll try to fly it out there.
Try to pump it out there. Well, it's way over the arm on it.
Very good. And now, slow, slow, slow.
It's kind of hard.
Yes, I know.
Let go, let go.
Okay,
Oh,
that's good.
super.
Very good. Perfect.
Perfect, perfect.
Okay, now we stabilize.
That was,
Very good.
Perfect.
Excellent.
Good, great.
Perfecto.
Okay.
Acá la estrategia para poder mover este trozo de roca, como acabamos de ver, fue solo prensarlo con el brazo de la ROV, pero como era un trozo demasiado grande y la ROV no podía levantarlo, entonces se tuvo que levantar todo el ROV, volar un poquito para arriba sosteniendo este pedazo de roca para luego movilizar todo el ROV a un lado y ponerlo en donde está en este momento. Esto tenía que hacerse con cuidado y con calma porque si no se podía romper el pedazo de roca a la mitad, que es algo que se quiere evitar.
Bitte? Okay, so
ahora se
we
van
want
a
to remove
tomar
the dead rift here.
videos cerca de
The
la
tube
roca.
one, the dead one. We want to remove it that we can actually see
Out of
the
the picture.
out of the picture.
This is not our
So
high,
selective.
not our highlight.
Ahora deben de quitar este tubo que está
So if you can grab it
de
somewhere
rifte
here,
sobre la
that
roca,
would be great.
removerlo ya que fue que se posicionó cuando se hizo el movimiento de la roca, no es que estaba ahí de manera natural, entonces hay que quitarlo para poder tener imágenes claras de la roca que está debajo.
Ah, die Wien ist ein anderer, sehr gut. Der Anna ist noch da.
Wenn der Fuhren lange hat und keine hat, daran erkennt die zwei, was wir uns gedacht haben. Die
Schau, da mal wieder die Röhren auch wieder. Ah, very nice. Schon wieder falsche Richtung.
Die zeigt nicht zum Vorderende jetzt, aber was es nicht, das ist glaube ich doch.
So Salva, you have to make a highlight frame up when you see that there's no shimmering water before. So now, for example,
no.
and just make a couple. You know, make a
Acá
couple of
se
pictures when you see in
está,
your screen that
se
it's
está
sharp, take a couple
intentando
of pictures.
tomar fotos selectivas de lo que estamos viendo en este momento. Como les decía anteriormente, el ROV puede tomar fotos cada minuto de todas las cámaras que tiene a su alrededor, pero también se pueden tomar fotos de manera manual en la que los científicos deciden, ok, vamos a tomar una foto en este momento específico y lo guardan como una observación por aparte con un número específico y con una descripción específica de lo que hay en la foto. Entonces, en este momento se está intentando tomar una de estas fotos manuales con descripciones de los científicos, esperando un momento en el que no se vea tanto el movimiento del agua caliente en la foto para que esté bien claro los organismos que están adheridos a la roca y poder analizar esto de manera posterior una vez que se termine la inmersión y la expedición en general.
Hmm?
No, it's not polycube.
It's a polycube. Shall we get Stefan?
This is in.
Is someone, André, could you get Stefan in here? André? André?
Yes,
Could you get Stefan for this?
sure.
Our polyheat specialist?
Vemos que debajo de la roca en este momento tenemos un gusano poliqueto. A pesar de ser gusano poliqueto, es una especie diferente a los gusanos riftia que vemos normalmente y diferentes a los serpúlidos que vemos normalmente adheridos a las rocas, estos gusanitos de tubos blancos pequeños. Ahorita las investigadoras están llamando a un investigador francés llamado Stefan, que él es especialista en poliquetos y de hecho ha estado en busca de colectas de poliquetos durante toda la expedición para que nos haga la identificación de qué tipo de poliqueto es este.
Yes.
No. What polyheat is this?
This is Nereis on the
Yes.
So they live in the underworld of hydrothermal vents.
They crawl very fast. I don't know if
No, we have seen it.
Yeah,
Like they
you've seen
flipped
it?
it. Yes,
Okay,
it
cool.
was
Came
no.
out of this, they go
Yeah.
in and out of this,
yeah.
and they came from there.
There were a
They
total
can-
of 3 on and 2 like escaped swimming.
There's a scale one on the right hand side as well.
Yes,
There is what?
this was also there in the
Sander-
picture when we
Sander
flipped the
sea.
rock.
Nereis, Sander, see this one.
The large one is Nereis, and do you? No, it's the shimmering water. It's a bit.
It's difficult there, but it's probably Branchignotoglouma.
Can you write this down, Salva?
What did you say?
That's mouse.
I'm glad we agree.
Hey, outside,
Yeah.
Acá Stefan acaba de decir que el gusano que estábamos viendo movilizarse largo es
But
en
here's the next
efecto
one.
un nereis, de género
Now
nereis.
this one was like, but there were like 2 of them. Were like so in total we saw 3 when we flipped the rock over.
Okay.
So there was no doubt that they were on there.
Okay.
2 were swimming away. You can also watch the video back, and 1 stayed, and this is this one.
Okay. Yeah.
And
We-
this
we-
red
we've-
dot was also on when we like flipped it.
So last time, the one we had the suction sample yesterday was Branchignotoglouma hesleri.
What is this?
That's pretty cool.
This, but I'm not sure if this was here before again. Like I think this was not here when we flipped it. I cannot see it.
Ja, das kann ich schon jetzt nicht.
Oh, Chris loves to focus by hand. The shimmering makes it very difficult. You pass it.
Yeah.
It was worse first, but we moved it.
Can we? Because here it's also shimmering. You know, it's like doesn't help us to.
Yeah, we had to move it pretty far.
It's cool. There's still some empty tubes on the rock
Yes,
as well.
and we want to make pictures, but
We want to take pictures because we cannot get it.
probably now it's a bit.
No.
No. But it's like here's one, over there. We have 3 nereis, 1 Branchignotoglouma, potentially.
It was pretty cool. You were able to suction under before you flip the rock. It was pretty cool.
Yeah,
you were able
yeah.
to suction
Yeah,
before
for
you
you
flip the
flip
rock,
rock,
so you're
yes.
pretty sure
Yep.
that what is
Yep.
in there
This
was
is from
down
there. Yeah. Yeah. That was the purpose of it.
I'm sure it was. I said, I
Very
appreciate
good.
that.
Very good. Thank you. So what should we do with this rock that we can make pictures when there's shimmering all over the places?
Branchignotoglouma.
Excuse me?
Maybe better on
This one?
on this camera.
On that camera. Oh yeah. Oh,
Branchignotoglouma hesleri. That's understand.
yeah, it's a good one. Okay. Monika, sollen wir da Fotos machen? Das sieht man besser.
That's the hesleri, probably.
Yeah, but this is better.
This is better, I think.
Man, this is on when we take the
Yeah, this is one, yeah.
This
Yeah.
is-
There you go. That's kind of clear for the setting.
Okay.
Take a
Yeah,
picture,
Salva, picture.
for the ones that I have problem.
Almost with 2 angles like this, we can almost make a 3D.
One connected to free form, but I don't
Pretty picture. Two angles.
Many with
This one, want to focus into this right one, the middle one.
But it doesn't get much closer.
I think you can get a little bit closer.
You have to look under a microscope to tell between side by side.
Yeah.
Then we just say
Branching onto Blumer.
Yeah. Good enough.
So one Branchinoto Blumer, Freneries.
And then we have some OSCs here also on it, dead tubes.
Yeah, I mean, maybe it's a software plugin or something, but I didn't check. I don't know.
Just start scanning from the sides, from the top, and we go down. And let's have a look there.
Yeah, but the important things that we like, the science frame drives and everything, they are captured. And the sample, so this is
But it's not that. It doesn't make any sense.
But here I can see in this one, in the other video.
Shimmering got more intense just now.
Probably now here it's getting better on my end.
This is better now and this is worse, which is funny.
Okay, so wait a little bit, Salva, and you now make a few pictures. Make just a couple of, make a couple that at one point we will get one that's sharp. Just click a few times.
Because here this one is two ones.
Acá se están solo intentando tomar varias fotos de lo que estamos viendo
Just now it's good, just keep taking
hasta
pictures.
lograr tener la foto indicada, clara,
Put some information.
para poder analizar luego.
Just make like 10 pictures, make just 10 pictures and one probably is good.
If you're lucky.
Yeah, if you're lucky. Now it's also good in the front.
This is the maximum you can squeeze. I'm just curious.
Like this.
What is the maximum? Because
This is the maximum.
Okay, show me.
There's one red thing
No,
in
show
there.
me. 1, 2, 3 at least.
And you see this little red thingy, oopsie, here in the back. And another one, we just make a couple.
Acá se puede ver en pantalla en estas formaciones de donde se seca la lava y forma los basaltos. Están pegados tubos bastante delgados de gusanos poliquetos. Si vemos en la formación que está un poquito a la derecha del centro de la pantalla, de color muy parecido al color del basalto, como de un cafecito un poco con tonos más amarillos. Se ven los tubos de estos organismos que en algún momento estuvieron ahí. No estamos viendo gusanos, además del poliqueto rosado que se está moviendo en la parte derecha en pantalla. Dentro de los tubos no hay gusanos, pero el que el tubo esté presente en la roca significa que el organismo estuvo ahí, vivió en este sitio. Así que esto es una prueba que valida mucho la hipótesis que se está intentando probar en esta expedición de que organismos y larvas de animales y microorganismos utilizan las ventilas hidrotermales para movilización y viven dentro del flujo de agua de estas ventilas.
Nice constant recovery.
Did you see the archaeonomic close to you?
Salva, now it's in focus.
Now it's in focus, this is all
Picture.
easier.
Highlight frame grab.
Tubes also, just that we can. From the left side, not the
Probably take one more to be sure it's in focus. And then we look what else do we have here that is currently in
So
focus.
you saw the archaeonomy next to the Nereus, right?
No.
Here? Or where?
This one, or where?
Ne.
Huh? What?
Zoom in.
What is it?
Ah, here.
Oh ja, Akinome.
Here.
Yeah.
Akinome rosacea.
This is like,
I was watching on my big screen. I was like, oh, I don't know if I can see that.
what do you call the people that dig in
estamos viendo otro poliqueto. Si vemos en la parte derecha de la pantalla, justo donde se está terminando de ir el gusano rosado grande, hay uno muy pequeñito. Ahora se movió la cámara, entonces está en el centro. Muy pequeño.
Okay, can make another highlight frame grab,
Arginome
and we
es
wait a
el
bit until
género.
hopefully it's getting
It's not focused,
focused. Yeah.
So if I see anything else, I'll pop back in. But, so there's probably another I can. No, it's not. Sorry, but that one. Also
También hace unos minutos se vio un polinoide, que es otro tipo de poliqueto que tiene como unas escamas en su parte dorsal.
I'm sure we find some copy points.
Can see them.
Worm's getting attacked by a amphipod thing.
Which one?
This worm, it just retracted. This thing chased it back up the slope.
When contact, it just.
Yeah, it like originally happened down here, and it retracts it up, and then amphipod keeps cruising up. Chased it up with the left, and then came back down.
Was ist denn da hinten?
Just because they are predators, so they would eat the amphibian.
Yeah.
They were given the opportunity.
Yeah, it was very odd.
Could we try to get this here sharp? Ja, genau. What's this? I don't know. Okay, thank you. No. Okay, where else should we look?
En este momento se hacen acercamientos a cualquier mancha de color interesante, forma que llame la atención para enfocar y analizar qué tipo de organismo
Take a
es.
frame grab. And also this limpet was also already here when we flipped it.
Acá podemos ver también en el centro a la derecha un círculo
The
blanco
limpets.
grande pegado a la
Did you
roca.
take
Esto
a
es
frame
una
grab?
lava.
Yes, very good. That's a tube bomb.
It is? Okay.
Yes. Tube bomb. Then the limpets.
Is that newly settled?
Was?
Newly settled?
And so I will probably take again a few that we get a sharp one.
Because they have a certain size and not
Yeah. Like how old do you think is that?
I don't know. I mean, who knows how fast they grow when they're small? I think it doesn't take long.
Yeah.
Maybe a few months when you like this.
So we also have a Lepidotrilus. So it's a little bit
But they're like
Few days?
small. Nowadays,
Few
no.
weeks?
Yeah, few weeks for sure.
Okay.
Or not a few weeks. Then.
Lepidotrilus. Dead tubes.
Yes.
Plus. So we had one Branchinotopluma, 3 Nereis, 1 Achinoma rosacea, 1 Lepidotrilus, and dead tubes 50 or this year, like plus 20 or plus 15, plus 15, 15. Okay, then we go a bit down. Yeah.
I'm not sure what's going on, but
It's like the movie Goons.
Ja, genau. Das ist halt einfach, ja. Wieso glaubst du, dass das Labor ist hier so?
It's game this up,
Also das haben alle da, trifft das nicht so. Das Regular sind ja auch diese Stränge nicht so. Und die Daphne macht das auch nicht.
There's another limpet. Look. Oops, one more limpet.
Kann man was bestimmen?
Can you take a highlight?
Or limpy.
One more limpet.
Okay.
And what is this here?
Ja, das ist scheiße.
And here's also something. Very good. It's more than 15 tuples. It's like more than 20 for sure, at least 20.
And in the center, that's the
En la roca hasta el momento lo que hemos visto son varios
This one
poliquetos
is not
y
crawling in. You have to
la
remember
doctora
this is not
Sabine está comentando que se han visto al menos 20 tubos, es decir, 20 individuos en solo esta sección de roca. Más allá de individuos, es más 20 trazas de estos individuos, ya que lo que estamos viendo por ahora son solo los tubos de los gusanos, no el gusano en sí.
Die war da oben mittendrin. Was ist denn das da? Das ist aber was Festsitzendes. Oder? Ja, das ist kalt. Was haben wir da? Can we take a highlight frame grab? I don't know if this helps. It's gonna tube, ja, genau. 2, 3, 4, ja. Okay, passt, oder?
Ja, wie passt es? Wenn wir geht auf die andere Seite, dann schon.
Welche? Sollen wir nochmal ein gutes Foto da machen, gell? Overview. Ups.
Haben wir ja schon.
Ja, machen wir nochmal eins.
Machen wir nochmal eins.
Okay, vielleicht mit einem Loch daneben. So, okay, we make a highlight. Can we get some more light probably to see if it's... And take another one. Den da hat es angepresselt. Sollen wir den zuerst einpacken?
Ja, ein Foto abgreifen kann, ich glaube, das ist vielleicht nicht. Ich weiß es nicht, müsst fragen. Also, das kann man schon auf der anderen Seite sehen, muss man eigentlich schauen.
So, die Box ist relativ neu, die andere, gell?
Aber die Box muss ich zuerst machen. Ja, den sammeln noch da.
Den kleinen machst du?
Den kleinen, ja. Ich meine, je mehr wir haben, desto mehr kann ich es oben, oder desto mehr kann ich irgendwie...
Is it possible to grab this rock here and put it in the cooler? Or are we too far away?
No, we can reach that.
So, möchte ich da mal schauen? Bringt nichts, gell? Da stimmt so. Sieht man nichts.
Du weißt jetzt nicht mehr, du musst glaube ich wirklich schnell sein.
Ja. Aber das war jetzt nicht gut, da haben wir gesehen, ist der Fiction und so.
Ausschieben irgendwie und schnell sein.
Ja. En este momento se está haciendo un acercamiento en pantalla de una roca más pequeña. Se va a intentar colectar, ya que la roca grande es sumamente pesada y no cabe en las cajas que tiene el ROV para las colectas. Así que vamos a agarrar una de estas rocas que estaba a un lado, que es de un tamaño más pequeño.
Genau. Die hat nur so, also das, was man, es ist schon so das Zeugs rausgekommen, wenn man was eingesammelt hat, aber viel weniger. Sicher, also eingeschätzt ein Viertel vielleicht von dem, nur weniger. tube rooms or in general? So like 20 plus tube rooms, one continent to Blumer, 3 Nereis, 1 Avenue Rosazzi and 2 liquids.
You're not planning to bring the big
It's not possible. It's bigger than our cooler.
Oh, it was, is it actually bigger than the last?
I think so.
It'd be hard to take out.
Yeah.
It's possible to make this go I find
But actually the small ones are also better for us to look at in the lab. Because this we can also turn around, the others not.
Acá uno de los investigadores principales estaba preguntando, justamente acaba de entrar a la sala de comando y preguntaba si no íbamos a colectar la roca grande que acabamos de observar, y justamente los pilotos dijeron que sería muy difícil subir este pedazo de roca ya que es sumamente pesado. Y después la investigadora principal comentaba que los trozos de roca más pequeños son más fáciles de ver en el laboratorio porque se pueden mover y manejar con mayor facilidad. El día de ayer en la noche, y cuando se estaba analizando la roca grande que se había colectado el día anterior, perdón, fue la noche de antier, cuando se estaba analizando la roca grande colectada, se tuvo que dejar la roca en el piso porque no se podía levantar a ninguna de las mesas del laboratorio, y el estereoscopio con el que se analizó se tuvo que poner encima de una caja, y la investigadora Mónica se sentó en unas almohadas puestas en el piso y de cuclillas estaba analizando cada centímetro de la roca. Entonces fue un setup un poco complicado, pero bueno, se logró utilizar la creatividad para poder acoplar el equipo al tamaño de la muestra y poder analizar todo lo que estaba adherido a ella. Así que justamente por esa razón es que se prefieren trozos más pequeños, y las rocas grandes se analizan con videos sumamente acercados, con mucho zoom, para poder analizar todo lo que tienen en ellas.
Monica, do you want more rocks or are you happy with 2 rocks?
Monica, do you want more rock?
Or are you happy? That one is already collected, yes? So we have now 2 rocks inside. I don't know if you want also this one here, so we could also try. This one. This could probably also work. Yes. They have too big? We have like 2 rocks inside now. This is enough for...
If you can fold in, or if you
Can we try?
You can also break, I don't care.
This is like playing like off the seabed.
Huh?
Oh, we'll be fine.
You're saying that. Might be time to go in, we are.
Still have a cable not attached.
You just pull it,
Oh yeah.
pull your...
What do we have cable?
Ahora se va a intentar tomar el otro segmento de basalto, un poco más grande, aún así mucho más pequeño del segmento que se analizó ahora por medio de la cámara. Vamos a ver si no es tan pesado y si cabe en la caja para muestras de la ROP.
Yeah, I'm just trying to think what's the best I can do for it.
Kannst du das Swap-Ding wieder aufnehmen?
That thing's pretty big.
Nein.
From the side
Nein,
there.
das ist schon, aber das müsstest du dann irgendwie, dass du gut verstauen können. Da müsste aber auch schon wieder sein, das muss man sagen. Genau. Das ist jetzt wieder riesig. That's going too big, huh? Yeah. Da kann ich wieder nichts tragen. Oder can you reach this one here? But this is also big. It's a bit smaller than that one. So. No, man sieht nichts. You cannot see. It's very difficult to see. Yeah.
Scoot up and then scoot back.
I would be more interested to look at the other side. Also, wir müssen bleiben lassen. Aber lassen wir es. Ja, okay. One last try and then we stop here. Wie viel Zeit haben wir eigentlich? Eine Stunde, das passt, genau. Jetzt können wir um die Ecken die rühren, wenn wir suchen. Genau. Das ist alles, was wir gesagt haben. Genau. Okay. Ah, now it's breaking.
How about this one here?
Yes.
Yes.
It's actually
Well, also this one.
Which one?
This one is also
on the
fast.
back here. I just nice.
This one is, man, it needs to be, I cannot see what this is because it should
Be
have
inside,
the underside and not the top, basically. But I cannot see
You
what
cannot
you
see it with
right
the
now.
shimmering. Yeah.
Yeah, I don't even know what is there. This is like blind. Du also.
Whoa. What's this?
Shall we go? Ah,
That black there on the left there.
shall we go? Brechen.
Wenn ein Arm gebrochen ist, dann geht's eh. Glaube ich.
Aber wenn das nicht. Oh, der wird groß, ne?
Na, ich glaube, mal schauen.
Was?
Schauen wir mal.
Willst du sehen, wie groß das ist?
No.
Sicher, kommt immer was. Schau das an. So, jetzt kann man. Das ist zu groß.
Sollen wir aufnehmen?
Ja.
No, we have enough. It's
If
good.
I look at them, the two good ones you collected, and if I want to collect more, then I
There's one breaking. Huh, this we take. Here, that just broke off.
A little bit.
Yeah,
Right there.
jetzt bröselt sie, jetzt kann man alles.
What's the point?
Yeah, but I can't see it on the screen, so I don't know
Hold on.
what we're looking at.
It's gonna be.
Here, this one. Destroying the screen. This one here. Is this one over there? But it's very super difficult. It's like blindly.
Difficult enough to grab it.
Yeah.
To grab it like without seeing is even more complicated.
What?
You see me have that?
On which one?
Main.
Acá en la sala de comandos, para poder señalar cuáles rocas se quieren colectar, se tienen unos punteros largos y se toca en la pantalla exactamente qué es a lo que uno se está refiriendo, porque las pantallas quedan un poco lejos, quedan del otro lado de la mesa en donde están los controles. Entonces las investigadoras en la pantalla que tienen al frente señalan qué es lo que desean y los pilotos que están al lado lo ven en sus pantallas en los diferentes ángulos de las diferentes cámaras que tiene el ROV para poder tomar la colecta. Justamente estaban diciendo que el movimiento del agua dificultaba el poder identificar qué era lo que estaban señalando en una de las pantallas, pero sí se pudo colectar, como vemos ahorita, un pequeño trozo de el hueco que se hizo en los basaltos. Justamente se desprendió último minuto, así que eso fue lo que se colectó.
Very good. And we can close the cooler and leave it closed.
You say this.
I've said this before, okay? Sorry. Cannot trust me.
I learned it's a scientist thing, it's not a
Yeah.
thing.
Yeah, that's not true. That's like, yeah, we're just gonna go around town.
My favorite is we're just gonna transit from here to there, we're not gonna stop, we're not gonna do anything. I'm like, okay, sure.
Yeah, that means
Alright, you
Can close it.
Sure.
Yes.
You sure?
100% sure.
100% sure.
100% science sure. Unless there's another, I don't know.
There's something really exciting, then we open it again.
As soon as I shut this, is gonna find it, right?
100% sure unless we're not.
Okay, very good. Okay, then
Ya se terminaron
Yeah,
las
we have to close it
colectas
with the
de rocas hasta el momento. Las científicas y los pilotos estaban bromeando de que solo si aparece algo muy muy interesante se vuelve a intentar muestrear rocas para estar seguros de que ya podemos avanzar con la siguiente sección del buceo del día de hoy.
So the next number would be
That's the thing, you know.
I have this number,
Right, there's
so
one.
okay.
I just want to write down.
Yeah, that's the thing that I don't use. Charlie, go find it. Something out there.
I mean, is it that one right there? The orange?
Yeah, okay. So that's Charlie.
Just got a hook on it.
A picture of the rock with a scale on it, of the lasers. After this is closed.
Want to pour out? Pour in?
And we can relate back.
Pour out?
No,
Okay.
sorry.
It's underneath the, HBR.
Oh,
HB fine. Alright. I'll portion out some more.
120, ja.
Portion out some more.
Und Polychetnässe Nereis, den Gala, Oasisia, Arginome.
It's fine.
Was haben wir noch?
Acá lo que estamos viendo es un mecate que se tiene para poder sellar bien esta caja, que como podemos ver fue una añadidura muy creativa del equipo científico a último minuto a la Rubin. Es una hielera muy grande que no está hecha para tener un sello fijo, así que se tiene que poner este mecate elástico para poder mantener cerrada la tapa durante todo el movimiento del resto del buceo y el ascenso a superficie. Se añadió esta hielera para poder tener muestras grandes y mantener la temperatura del agua, porque como vemos en pantalla, en la esquina inferior izquierda tenemos las lecturas de temperatura y esta zona normalmente está a un poquito menos de los 2 grados centígrados, entonces es agua muy fría. y nos estaba pasando que cuando llegaban las muestras a superficie el agua estaba en casi 17 grados, 12 grados, lo cual es sumamente caliente para los organismos que viven acá, y los organismos se estresaban térmicamente y llegaban incluso muertos a superficie, entonces no se podían utilizar para los experimentos que se tienen diseñados a bordo. Así que se decidió poner esta hielera. Las hieleras tienen espacio hueco entre la parte de adentro y la parte externa, así que se le perforaron orificios para que entrara el agua y así no hubiese aire que pudiese ser comprimido por la presión. Y se añadió en la plataforma que se retracta del ROV. De esta manera la hielera tomó el lugar de la biobox grande que teníamos anteriormente en el ROV para tomar muestras de gran tamaño. Y fue sumamente exitosa. La temperatura del agua de la hielera cuando llega a superficie es de 6 grados centígrados, un poco menos. Y los animales llegan vivos y perfectos para poder ser utilizados en los experimentos a bordo.
What's that? Yeah, I got rid of the box here.
En este momento estamos viendo unos puntitos verdes que están sobre la roca grande. El espacio entre un punto y otro es de 10 centímetros. Y estos puntos, estas luces son unos láseres que tiene el ROV. Y esto se toma como escala para poder saber aproximadamente el tamaño de las cosas que estamos viendo en pantalla.
Digging site.
Okay.
And go just around the around the corner for the small tube-worm collection in the bio box. The small bio box we have.
Ahora vamos a colectar gusanos riftia para los experimentos justamente. Se necesitan gusanos de tamaño pequeño, mediano, por lo que se van a colocar en otro biobox, no en el grande, sino en uno más chico.
Oh, the box need to be covered. Sorry. Sorry.
If you want to do that after we get the
No, I think-
it'd be a lot harder to collect them and
Is it
then.
kind of,
Okay, how then we need to estimate the time to go back and collect, no?
Last time we did it.
Se debe también de colectar la caja de malla del experimento que no se ha podido guardar todavía. Entonces, como no se hizo en este momento, vamos a tener que calcular el tiempo para ver si nos da chance de tomar todas las muestras que se necesitan y luego volver por la caja del experimento que debe ser recogida. Con esas imágenes, mientras nos volvemos a movilizar para poder colectar los gusanos riftia, yo me despido. Gracias por acompañarnos en este espacio de la expedición. La expedición sigue, el live no se acaba y tenemos todavía bastante tiempo en el fondo. Probablemente el ROV empiece su ascenso dentro de una hora, un poco menos. Así que los invito a quedarse por acá. Muchas gracias y nos vamos a ver mañana, ya que hay espacio de narración en español todos los días alrededor de las 2:30 de la tarde. Muchas gracias y nos vemos. Seguimos con la inmersión.
Dropped it too low.
No more than normal.
We got area now, so.
Yeah, maybe around here somewhere. You can look. I don't know if there's more ones, but they are always.
So thank you again to Yvonne for some fantastic narration for the past hour. Speaking of, we have about an hour left of planned dive time on the bottom. So we're just working to finish up the last of our objectives for the dive. For anyone just tuning in, so far this dive has been working primarily around experiment number 2. We worked to sample the fluids inside experiment number 2, and then also lifted the box, did some suction sampling underneath, did a little bit of sampling of the surface, and then also cracked out some larger rocks again, fluid samples, and took some of those rock samples. We're now looking to collect some worms, it looks like. Some of these Riftia tube worms. So we have about a half hour to do this, and then head back and spend some time putting the experiment box back on the porch for recovery. Internet looks like it's holding strong. And the weather's looking about the same as it was. So hopefully we are able to stream that recovery for you today over on YouTube.
There's some small ones you can see, like right at the top of
Those here, or those here?
I was looking at that one, so probably the top of yeah. See what I said.
I don't even like the 45 are going in. What can you do? What is the news? Ah, okay, so I got the... Okay, basta. Okay, okay, basta. Okay. No idea. Small and large is very
Alright,
Alright, we'll yeah, we'll get some and we'll push out. Essentially get from this place.
I think the easy access to get to Okay.
You try to collect them individually?
That's what we're doing yesterday, and it worked pretty good.
Okay, then collect them.
Just gotta make sure the movie heads down there on the road.
Yeah, if they're not really in, then you do this. I think this is inside already.
Go for this one.
Yeah.
It's already
Alright, so if you haven't been around for one of these collection sessions just yet with the tube worms, got to first kind of prompt the tube worm to tuck back into its tube, and then you're able to kind of grip the tube in the area where the worm is no longer occupying it, and just pluck them out.
So much of a challenge, huh? Only 20.
Monica,
Yeah.
what side down there?
This is Fava Flow. This is
Four.
Other, and then just write Fava Flow.
Okay with that? Wander fast?
How does it look?
Yeah.
Toss it between the gray tube and
Yeah. Fava Vent, sorry. Fava Vent, it's called.
Did you see that without the airways? Can I see that open? That.
Fava Vent.
Fava Vent, yeah. Fava Flow, maybe I call it Fava Flow. Fava Flow.
Oh, that's just ridiculous. Just have to deal with it.
Alright. If you're fine with it, that's.
Is this the shop?
Yeah, we can sort that later. It's in the road, everything.
Okay.
Zoom in.
Yeah.
That's one
This here is, this you can take also, I think, and this.
Yeah.
I think the other one is the worm is really high up.
You told me to have located that computer. That is one of the times.
And all the photos for the figures. Images.
But it's not used.
No.
And the CSV 1.5.
Sorry?
1.5 the CSV. The
Do you know where it is?
I mean, I can find it, but you
Where?
fresh. Can you help me?
Yeah.
There it goes last year. This is the first time.
The first time I tried.
So we want some other dive.
Yeah, right.
Second dive.
Okay, this thing is
Yeah,
driving nuts.
yeah.
See that?
And then there's a CSV.
This is what is.
CSV. These are download. And then images, and then I download the source for YouTube.
Oh, this is annoying.
No?
That's it.
Just get some road, haven't I? No way to do it.
Can you stick the handle in the handle?
Trying to.
Yeah.
This is very sharp.
That's a little bit dull at the moment.
Yeah.
There you go. I'll stay like that.
This is specific practice. You can sit like totally.
There we
Now
go.
you can take.
You're just being annoying.
Yeah.
It's like, nah.
What? What? That website?
So what would that mean if it refuses, if it doesn't?
Well, that's the developer, right?
Hm? Ja, der ging wieder zurück.
These ones, there's 2 ones in there as well.
Was it the 5th? No.
This. I have those. I have those.
I think that, see here, this is, there's no anybody here, you can,
But if you look up, I thought it was higher up.
no, high up, yeah, but I mean, they worked it so concerning to putting in the tube.
Oh, I
You see,
see.
it's no anymore, so it doesn't matter. This is a bit higher, so if this is bent, it doesn't matter.
Okay.
And also the last part really here, it never goes to the output, perfect.
There we go.
It's okay.
I can go. Sorry. Missed it. There you go.
No, I think sometimes it's like they go a little bit down, and then if you disturb a little bit, you get them further down. And
So now this one is in, but I think this might be also large. This is like in till here now. So the whole, but it's a difficult angle.
Can I just see that, please? No, it's too Wait, let's look down. See what's going on here. I need something closer.
Okay.
I can bring it up to the
Okay,
porch.
he's not here for it. He's one.
Mm-hmm. You count?
6.
Okay, good. Oh yeah.
So we're looking to collect about 20 of these, and Russ has become quite proficient at getting them.
Mm-hmm.
One right there. Let it go off through those things. So you speed things up.
Yeah, nice twofer there.
This one is tiny, no?
Yeah, I tried that one. Didn't know what to do.
Ah, okay. Oh, you tried this already, okay. Oh no, we're talking.
Just get big there, you know.
You're getting good. I don't see any. It's good. 1, 2, 3, 4, 5, 6, 7, I think, in one go. Great. How much is the silver now?
I count 16.
Okay, good.
How many males did you catch?
Yeah. Yeah.
It's important.
Yeah. Right.
I
as a next step.
Have we been getting an offset skew?
I'm more and more ambitious.
Yeah.
They look very good.
I think those are 5.
No way to use X externally on them.
Tiger.
No,
This is good.
Just looking at it.
Yeah.
Oh.
So we need to remove them from the tube.
Oh. So when they're in the tube, you can't tell.
No, because it's in the height, in the instrumental, you
I
can
think
see
those are 5.
they have groups.
Yeah.
It's male. If they're like smooth, they're
Yeah.
female.
And then the question I had a question about the waist. Is the waist like at the bottom of the tube, or do they really have much? in
21.
waist?
They don't have a
Get it in.
I guess that's fair. Yeah.
But what is metabolically left over
Oopsie,
from the
20.
bacteria or whatever goes back to the circular system and goes to the poop again. And the poop is easy. But they don't poop or they don't eat.
Yeah, I think
Is
we
that
should.
kind of like fish giving off ammonia through their gill?
Yeah,
Okay.
sure. Yeah.
All right, I had a couple questions in the chat. One was whether or not you could ID them just looking at them, male versus female, and no, you have to get them out of the tubes. And another question was, what do they do with waste? So the worms as adults don't have guts, so there's no real waste from the worm with regards to like a diet. But whatever is metabolically left over from either the bacteria or from filtration processes in the worm actually make its way back into the gills and are dispersed out into the water that way. Similar to some like fish will get rid of ammonia in their system through their gills as well.
All the pictures from the hydrological observation, all the pictures of sunspring, base and just sorting everything by hand. However, there's some evidence that are missing pictures.
This is cool.
They don't know that they're going to do that.
And the other one, the other arm is like, I won't tell you just what.
No, but the renovation
Oh, there's one.
Yeah, I was thinking
that
this.
that
This is not the one because it's supported now, so that's the daytime also. And all this.
You go for the far edge like that.
This is the one I can't call already, so.
All the pictures that are not there.
What with your pressure vessels do you have in it? You have in both pressure vessels something, no?
Yeah, but we checked yesterday, we took pictures, they are not dividing, they're only fertilized, but they're not moving further. So if we get sperms and eggs, I think I would just fix whatever it's in there and start again. We have
It's almost no time anymore.
Yeah, if we have 8 days, we could go to 3 rounds of division. That will be already something. Then we have juveniles, we have zygotes, eggs,
Okay.
and 8 cell stage and 4 cell
Okay.
stage.
Great, thanks a lot. That was speedy. A speedy, fast collection.
Alright, so back to the mesh box.
Right.
Slow her up.
And then we pack up everything and then we can.
Probably not take the bar today because it's got enough weight in the vehicle. We'll leave the bar down because it's already got quite a lot of weight with the rocks.
Well, we need to do that other.
The
experiment
bar,
today,
we
so-
need it anyway.
Leave it
We
anyway.
leave everything, yeah.
Good. Otherwise, we'll never get to the surface.
We leave everything.
All right, so we're gonna head back on over to experiment number 2 and collect up the mesh box for recovery.
This was,
That's a good start.
it was a good spot, but the better you get, the more easy it looks for me, you know. I mean,
Next time,
whereas I say, come on,
I need like 50.
you can do it in 5 minutes, you know. But this was now this was less than half an hour.
It was good.
It was very fast. I mean, but we just can store everything and then it's good.
So you can see we're going through some venting water here. The ambient pressures there got up to, well, they're still up over 3 degrees C. So a little warmer pocket right there. And now we're through that, it's dropping back down.
So there's something else right here.
Almost this.
Yeah, I can see the video. Honestly, there's a handle.
And far side.
This is
Yeah, as long as further,
So you can see experiment 2, which is the flipped over box there, and experiment 3, which will be, I believe, recovering in two more days' time. Not tomorrow, but the day after.
But this is the pictures in this folder. This is the same thing. But this is the picture folder. Yeah. And this is the same.
Yeah. So we're going to return now. This Q, Ctrl C.
And this?
state of the I would say something's wrong or something.
Alright. Okay, so I'm gonna grab it, we'll move somewhere away a little bit, and then we'll yeah.
So this area of 4 cameras.
Yep.
Do you want to get the
I'm gonna get all the budget ready first.
budget first? Alright.
Do it almost ready.
That's good. Pretty close.
So we got this actually. Oh, YouTube.
Unfortunate.
Flip it around.
Load it up for you.
Let's see this budget.
Alright.
So if you're just tuning in, we are approaching the end of our bottom time for today's dive. You're watching live footage from about 2,500 meters below the surface of the Pacific Ocean at a hydrothermally active area on the East Pacific Rise. Today we recovered, or we are in the process of recovering experiment number 2 of 3. You can still see 3 in the background there. We were also able to take collections and samples and some measurements of the temperature of the water, geological samples, some of the rocks in the area we were able to collect. And we also just went and collected roughly 20 Riftia tube worms to bring back to the surface. We are planning to stream the ascent back up to the surface through midwater. It's going to be about an hour and a half. We'll be streaming that over on our YouTube. But I'm going to be handing the mic over to Juliana for that. So if you're interested in that, just sit tight and we'll hopefully find some cool stuff on the way up.
Okay, if you're still with us, we hopefully have a more stable stream now for the ascent. We just left bottom maybe a few seconds ago. So we have the mesh box with us and gathered some tools, and we are now making our ascent to the surface. I will mute the mics, but we will stop and show you whatever we find. Thanks for sticking with us, and glad you're making the ascent with us back to the surface.
Okay, we are at 100 meters. We are going to commence with ROV recovery shortly here. Thank you for sticking with us. We saw some cool things on the way up. As always, we are diving at the same time tomorrow. We won't be recovering another experiment, but we will be checking on them. So we'll see you tomorrow, and hopefully we'll see some more life as we head towards the surface.
Pretty good current. He said, well,